Welcome, everyone, to Standing for Truth. My name is Donny Budinsky, and tonight we're diving headfirst into a special live program where we put the evidence and the critics to the test. Recently, we released a video from a larger program that we did responding to theistic evolutionist Redeemed Zoomer. And in this video clip, we showcased some of the most powerful scientific evidence for young Earth creation. Evidence that challenges the foundations of deep time geology and evolutionary assumptions. We discuss the accumulation of salt in the oceans, the cold, dense slabs found deep within the Earth's mantle, and the helium trapped inside zircon crystals that should not be there if the Earth really is billions of years old. All of these pieces of evidence strongly pointing to a young Earth. But not everybody agreed, and we're not surprised. One critic in particular, known as Creaky Blinder, has stepped up to debunk our work, issuing what he thinks are legitimate arguments to what we've said, but actually represent rescue devices to defend the old Earth model. The problem, those rescue devices don't work. And here in this program, we're going to show you guys exactly why with Ben and my award-winning co-host, Sam. And so, gentlemen, I'm excited to have you guys. Ben, my brother, you are really good at joining us to address criticisms and objections to young Earth creation. You've been here several times in the past. We've responded to William Lane Craig. We've responded to inspiring philosophy. We've responded to Redeemed Zoomer, and now today, Creaky Blinder, who's an atheist, from my understanding. So, Ben, how have you been, brother?
I've been good. It's been a fun summer. Starting up a new small group at church. There's a creation science Sunday school group at church I just went to for the first time last night. So they were talking about Noah's flood and stuff. So some of the same stuff we're going to talk about tonight.
Very good. Well, I'm excited. The summer flew by. The summer was busy, and we want to end the year with a bang. And I know people enjoy live response videos to the critics, and I do too. So I'm looking forward to this. Ben, thank you so much for being here. Sam, my brother, you were just here actually a couple times. We had an interview last week with Dr. Michael Egnor. Excellent discussion. And then just a few days ago with Lee Strobel. So Sam, how have you been, brother? How you doing today?
Been great. Thanks for having me back on. It's always a pleasure. I'm looking forward to seeing what Ben has to offer today. He's always got some very, very researched work to share with us. And so I'm looking forward to it.
Me as well. And so with intros out of the way to the audience tonight, we have Ben Kissling and Sam, and we are going to carefully and scientifically respond to Creaky Blinder's video point by point. And the question is this. I want you guys to ask yourselves this question. Has this so-called guardian of common descent really debunked the evidence for young Earth creation that we've presented? Or will the data once again confirm the truth of God's word? And before we go point by point thoroughly through his video, we are going to just play about 30 seconds of it, where he makes an assertion that there is no evidence for young Earth creation. And then Ben Kissling has a presentation, a comprehensive presentation that I'm really excited for, going over some of his favorite, if I'm not mistaken, 5 of his best pieces of evidence for young Earth creation. So guys, grab your Bible, grab your notebook, and get ready, because tonight we're setting the record straight on the science that confirms creation right here on Standing for Truth. Gentlemen, let's get right into it. I'm going to screen share and play the first little bit of his video, and then we're going to hand it to Ben here for a presentation that I'm excited for. Here we go. Screen should be shared. Video's up. The title of the video, Young Earth Creationist has no clue how science works. So I guess we're going to see how true that assertion is here today. Gentlemen, the audio should be playing. So here we go. To point out this comment, Andrew Cumming. There is no scientific support. What an assertion.
He's not wrong. There is, in fact, zero scientific support for young Earth creation. It's not a debatable point. It's the scientific consensus. The proofs you offer have been getting dismantled for decades. Just ask Kent Hovind.
Not a doctor. Shh.
What you're saying is like a flat earther trying to assert that gravity isn't real. It's a hilarious claim, but it does not change reality.
If I only had that amount of time, I would probably...
Okay, let's stop it there for now. As we can see, gentlemen, Creaky Blinder is quite confident that there is no evidence for young Earth creation, that whatever evidence we provide or offer has been dismantled for years and years. He says, and he even compares it to, well, firstly, he uses argument from consensus, a fallacy that we can get into. And secondly, he even compares it to flat Earth and their denial of gravity. But remind me, gentlemen, isn't that something, I mean, we can observe through experimentation? It's testable, it's repeatable. Evolution, and by evolution, obviously, he would mean all life is related through common ancestry. And the billions of years paradigm, not so much, which we're going to get into. So, Ben, just let me know when you're ready, brother. I think this is a good segue into your presentation to counter, obviously, very comprehensively what he's asserted here, Ben. So I'll put your slides up on the screen. I see the top 5 scientific evidences of young Earth creation. So, brother, the floor is yours. Go ahead.
Yeah, and I was concerned with something you said earlier about not everyone agrees, but I have it on good authority that everyone does agree. I found this quote somewhere on the internet from our illustrious president. So these are my top 5 lists. You'll find these on a lot of top lists, but I'm actually going to cheat a little bit because number 1, I'm actually going to include some evidences that are usually separated into 2 sets of evidence, but I like to present them together because they're connected. And I think that
Ben,
shows...
Sorry to interrupt you, brother. I wonder if, can you see that at the very top? It's covering a little bit of the headline, catastrophic plate tectonics. When you go full screen, you could probably hit hide. If you put, yeah. Do you see that?
Oh, this guy?
Yeah. So if you, there we go.
All right.
Good.
Sorry.
Oh,
Okay. All right. So I'm going to go 1 through 5 because I like this one a lot. I'm going to spend a lot of time on this. So catastrophic plate tectonics is the best flood model currently available. And if you dig deep enough, most of the major young Earth creationist organizations will admit that. But flood models are notoriously controversial within the young Earth community, but hopefully I can explain to you why this is the preferred model. This model was developed by Dr. John Baumgartner, who's currently a research professor at Liberty University, but he came up with this in the early 1980s when he was doing his PhD and post-PhD work at Los Alamos National Laboratory, which is the place where the nuclear testing program was done in the 1940s. Okay, Baumgartner came up through the Navy. He got his PhD from UCLA, but he worked at Los Alamos all through his PhD and afterwards. And he asked them, can I work on young Earth creation stuff with half of my time here if I take this job? And they told him he could, which was very rare in those days. It's rare today even. So he had this opportunity to do government-funded research in a top laboratory, and he ended up developing this model that has come up with what I would say are 3 successful predictions with his model and related models to it that also involved Russell Humphreys. Okay, so we're going to talk about all 3 of these. But first, I need to explain what catastrophic plate tectonics is. So I want you to think of the Earth as a waterbed, like you see before you on the screen. The surface of the Earth, or the crust of the Earth, would be the skin of the waterbed, and the mantle is the water inside. Now, the mantle is technically a solid, but because it's so hot, it behaves like a really viscous or really thick fluid. Okay, and so it does flow. And what Baumgartner did was developed a computer program called, if I can back up here, called Terra, right here, that is still in use today in a major climate model. And I know that Baumgartner still has contacts in the secular community based on this climate model, because it still uses his program called Terra that he used to model flows in the Earth's mantle. Okay, and so I want you to think of the mantle as kind of like a liquid, even though technically it isn't. And what happens when a weight is put down on one side of the waterbed, right? You lie on one side of the waterbed, that side goes down because of your weight, and the other side goes up, just like this. And if you roll to the other side of the waterbed, it'll go down on that side and up back on the other side, okay? And so what Baumgartner realized is that the surface of the Earth is kind of like this, that the low parts are the crust of the ocean, and they're lower today because they're heavier, they're more dense. And so they sink lower in the mantle, and therefore that's where all the water gathers, because that's lower. And the continental crust sits up higher, okay? So what Baumgartner proposed is that prior to the flood, what happened was the crust of the Earth underneath the oceans broke off from the continental crust and subducted underneath it into the mantle. Now, what that would do is that would suddenly and rapidly expose the bottom of the ocean to the hot mantle material. And what that means is, as you know, hot things are less dense. And so that rose higher and higher and higher as the cold crust subducted off into the mantle, pushing the water from the oceans up onto the continents. And as the seafloor rose, the displacement of the mantle also made the continental crust sink a little bit as well. And so the bottom of the ocean didn't quite equilibrate with the tops of the mountains, right? Because we know that if it was completely flat, the whole Earth, the water on the Earth today would cover the whole Earth to a depth of about, I think, 1.6 miles or something like that. So it probably wasn't that bad. It wasn't totally flat, but it was raised up enough so that it pushed the water over onto the continents and flooded the whole Earth. Now, just like when you jump on a waterbed and it bounces a little bit, right? You've done that before. That's what we call oscillation. So it oscillates back and forth. This also, Baumgartner's model showed, happened to the Earth. And so the Earth and the continental crust and the oceanic crust are oscillating back and forth, which means that the water is going to be sloshing back and forth on and off the continents, a perfect explanation for the layers in the fossil record. Okay, so if anyone tells you we don't have an explanation for the layering in the fossil record, say catastrophic plate tectonics. That is a really good explanation for why there are layers in the fossil record on a young Earth model. It also explains why there are different animal groupings in different layers. It's because as the plates subducted off, the oceanic crust rose higher and higher while it was oscillating, and it flooded different ecosystems based on elevation in the pre-flood world. And so there were different animals living closer to the coast, just like today. This is also true today. There are different groups of animals closer to the coast than farther inland and up on mountains, okay? There are a lot of other things this explains, but I don't want to go too long, so. Now, Baumgartner also showed the mechanism by which the plates subducted rapidly into the mantle. Today, plate subduction is occurring, but it's very slow. And so this is not fast enough to cause a flood in the space of, a few months to a year. And so Baumgartner found research on what's called olivine rock. It's a type of rock in the Earth's crust, showing that under very high heat and pressure and what's called shearing force, which generates friction, right? Shearing force is when two things are pressing against each other and sliding against each other. As the rock is under this shearing force, and as it heats up from the friction from the shearing force, it breaks down or deforms the crystal structure of the rock. And what that does is it makes it more dense. And so under these special conditions, rock getting hotter actually doesn't get less dense like it would normally, like it does on the ocean floor at a different location. Okay, instead it gets more dense. And as it gets more dense, it sinks faster, or more inevitably, let's say, but faster. And as it sinks faster, that generates more friction and more shearing force, which generates more heat, which in turn deforms it even more and causes it to get even more dense. So you have what's called a positive feedback mechanism. It feeds into itself, which means this system is going to get faster and faster and faster and sink farther and farther and farther until it can't sink anymore. And so Baumgartner's model predicts that the pre-flood oceanic crusts would subduct all the way to the core of the Earth. Okay. And he also thinks that the rate of subduction today is really just residual movement left over from the flood, which, by the way, the secular model has not explained how plate tectonics started. They don't know how it started or where it came from. Okay, this is a really good explanation. And so this process I described to you is called thermal runaway, where because of the heat, it actually increases in density, unlike a hot air balloon, which decreases in density with heat. Okay. Let's just move on. So this is a picture from one of Baumgartner's papers showing the cold slabs that they found near the Earth's core. Those are the blue areas in this diagram. The red area is a hot area that has been pushed up or displaced by the cold area, is what it looks like. And these cold areas near the Earth's core are exactly what Baumgartner predicts would be the case. And it is also evidence for a young Earth, because over a long period of time, these cold spots should have equilibrated with the rest of the mantle, but they haven't, and therefore they haven't been down there very long. Okay, at the very least, these cold spots themselves are new, are recent. And also they must have gotten down there rapidly somehow, because if they went down there slowly, like the current rate of subduction, that rate is slow enough for all the material to have equilibrated in temperature as well. So the fact that it's cold and it's way down there means that it happened recently and it happened rapidly. Now, Russell Humphreys is another physicist and a contemporary of Baumgartner's who noticed this, also seemed to provide a mechanism for polarity reversals in the Earth's magnetic field. Why? Because when these cold spots hit near the core of the Earth, they disrupt the electrical current that we believe is circulating in the core of the Earth that generates the Earth's magnetic field. Okay? And so when these cold spots, these cold slabs that are, again, the pre-flood oceanic crust that have subducted, when they hit the core, they cause a dramatic temperature difference between them and the core, and that disrupts these electrical currents. And it causes polarity reversals in the Earth's magnetic field, which also is unclear how that happens on a secular view. Okay, now we actually agree with the old agers here that there were polarity reversals in Earth's past. And we know this because of the striping pattern you see on the bottom left on the ocean floors. Okay, now this is a striping pattern of diamagnetic and ferromagnetic materials in the rock. And what happens is as plate tectonics moves the crusts of the ocean apart, this is like a mid-Atlantic ridge or something, they're coming apart in the center, and hot magma is coming up from below, from the mantle, and slowly cooling and forming new ocean crust as the seafloor spreads. Okay. And when it's hot and liquidy, or at least more liquid, at least above about 500 degrees Celsius, these ferromagnetic and diamagnetic materials are free to orient themselves in the direction of the Earth's magnetic field, just like a compass. Okay, but as they cool down, they get locked in and they can't rotate anymore. And so what we see on the ocean floor is these striping patterns of these ferromagnetic materials pointing one way in one stripe and then in another way and then back again in several. And so this is really good evidence that the polarity of the Earth's magnetic field has reversed many times in Earth's past. There's evidence for at least 26 reversals in Earth's past. And everyone agrees on this. This is not controversial. What is controversial is the rate at which it occurred. Okay, I already explained all that. So what Humphreys did was he predicted that there would be evidence of rapid polarity reversals in the Earth's magnetic field. So this is prediction number 2. Prediction number 1, coming from Baumgartner's theory, is the cold slabs near the Earth's core, which have been found. Prediction number 2 is Humphreys' prediction that we would find evidence of rapid polarity reversals. Now, how would we do that? Well, the seafloor is too thick. And the problem here is that this is not, as Donny is fond of saying, discriminating evidence between the two models. Because on the old age model, they're always moving slowly and they'll cool slowly because they're thick, and that fits their model. Whereas the young Earth would say, no, in the past, they were moving rapidly and they cooled also rapidly, or rather the polarity reversals occurred rapidly, right? But because the plate tectonics was also rapid, it leads to the same result as an old Earth, where both processes are slow. So they're both slow together or fast together, and so you can't discriminate on the basis of the seafloor evidence. But Humphreys suggested that we might be able to find really thin lava flows coming from volcanic activity with this striping pattern in it. And that would be evidence of rapid polarity reversals because thin lava flows cool much faster than the thick seafloor. And so because we know it would cool faster, if we find this striping pattern in them, we would know that the polarity reversals occurred rapidly in the amount of time it takes for that thin lava flow to cool. And as it turns out, a couple of secular geologists found this evidence within a few years of Humphreys making this prediction. And they published it in the secular literature without knowing that they were confirming Humphreys' prediction. And it was so bad that one of them years later tried to retract his paper and claim that there was something wrong with it. And so there was a few years of Humphreys arguing with him about this. But this is a dramatic example of a confirmed successful prediction by a young earther based on a young Earth model. So here's a GIF I found of this that just kind of shows the process of seafloor spreading and the striping pattern that results. So you can kind of see it in action there, where at each stripe is showing the ferromagnetic materials orienting one way, and then as it cools down, they get locked in, right? And then the polarity of their magnetic field switches, and the stuff that's in the hot magma that's newer will orient correctly, while the old stuff that's cold won't, right? And so it gets locked into this striping pattern. All right, now the third piece of evidence that came from all this is Humphreys came up with a model of the Earth's magnetic field as a result. And he went back and looked at a scientist named Barnes, who had shown that the measurements of the strength of the Earth's magnetic field, or rather I believe the total energy, had been decreasing for about a century. And he showed that it was decreasing at the rate of about 5% per century. And at the time, it had decreased a total of about 7% since the time it was started to be measured. And so we would expect this because if the magnetic field is caused by an electrical current in the Earth's core, then it would be affected by resistance in the Earth's core, which would slowly over time take energy out of that electrical current until it doesn't exist anymore. Now, of course, you see where I'm going with this. Over billions of years, it would have been totally gone. Okay, and so the secular model, they have to invent some way to keep adding energy to this current somehow to keep it alive. Otherwise, it should have been gone by now. Okay, and so the secular community came up with this different alternative theory to what Humphreys' theory was, because they have to explain how the Earth's magnetic field has lasted so long. Whereas Humphreys and young earthers can just say, no, it had this initial amount and it's been decaying ever since, and we just haven't lost it yet. Okay. So here's another example of discriminating evidence, right? You have two different models. Okay. How could you discriminate between them? Well, Humphreys realized that the magnetic field strengths of some of the outer planets, Uranus and Neptune, had not been measured yet. In the 1980s when he was doing all this work. And so he made a prediction of what those magnetic field strengths would be based on a biblically based young Earth model of how the magnetic fields originally formed on Earth and on the other planets. And this is based on the tiny magnetic field of a hydrogen atom. So in Genesis 1 verse 2, remember it says, in the Spirit of God, now the earth was formless and void, and the Spirit of God was hovering over the waters. Seems to imply that the earth was water in the beginning. Okay, and so Humphreys says, okay, what if the earth and the other planets actually started out as water, or H2O, as you see on the bottom right here, 1 oxygen and 2 hydrogens. Now, oxygen does not, the oxygen nucleus does not have a magnetic field, but hydrogen does. And so Humphreys suggested that at the instant of creation, or the moment of creation, God created all the hydrogen atoms in the water to be perfectly aligned. And what this would do is it would combine the strengths of all their tiny little magnetic fields into one giant magnetic field. Okay, so today that doesn't happen because you see on the left there's no magnetic field. All the hydrogen atoms are affected by entropy and they're all jumbled up, and so they cancel each other out. But at the very moment of creation, Humphreys suggested the magnetic field of the Earth would have been created by the summation of all these tiny magnetic fields of hydrogen. And he calculated what that would be based on the mass of the Earth in water. Okay. And so when you add up magnets, like on the right there, their magnetic field, this is just showing that how their magnetic fields add up. Okay, and so he calculated an initial field strength based on this theory for the Earth and the other planets, and then calculated from an exponential decay curve how much it would have decayed over 6,000 years and made a prediction. Okay. Now on Earth, it was a little off if you just go straight back. So it goes to about 8,000 years old. And so Humphreys suggested that maybe it lost a significant amount of energy at the flood, and that accounts for the discrepancy. And this is his model of what happened on the Earth, including the polarity reversals that would have occurred at the flood and the larger decay curve throughout time and where we are now and everything. Okay. So when they measured the magnetic field of Uranus, it was within a factor of 2 of Humphreys' prediction, and the secular prediction was off by a magnitude of about 100,000, many orders of magnitude off. And so Humphreys' prediction would be considered, if people were being fair, a successful prediction, because in astronomy, a factor of 2 is nothing. For example, the famous prediction of the energy, or the temperature rather, of the cosmic microwave background that was considered to be such great confirmation of the Big Bang model was actually off by a factor of 2. And it was only one of the predictions. There were other predictions that were off by more, but the prediction was 5 Kelvin. The actual measurement was 2.73 Kelvin. So that's off by about a factor of 2, and that was considered successful confirmation of the Big Bang theory. So this should be considered confirmation of Russell Humphreys' theory. The heat dynamo theory is the secular theory for how the magnetic field can be regenerated over time. And it has to do with the rotation of the Earth, imparting some rotational energy to the core that somehow then, speeds up the electrical current in the core. It's not a very good theory. And a big problem is that it does not work with Uranus. Now, we used to think Uranus has no measurable internal heat, but I looked this up recently, and it turns out like they have found some measurable internal heat from Uranus. Apparently, it gives off about 12.5% more energy than it takes in from the sun. So apparently, it does have some internal heat. So that matters because in order for the heat dynamo theory to work, you need a molten core. Otherwise, it's a non-starter. Okay, Humphreys' theory would still work. But the problem is it still doesn't work for Uranus because Uranus rotates at a degree offset of about 60 degrees off from its magnetic field. Okay. And so you can't rotate 60 degrees off from the magnetic field and provide energy to an electrical current that's going around in a circle in a completely different orientation. So it just doesn't work for Uranus at all. It still doesn't really work for Earth because of technical reasons that they still have not figured out. And so we should consider this a dramatic success for the young Earth creation model. So I've gone over 3 evidences that are all interrelated. Cold slabs in the mantle must be young, and this is a prediction of Baumgartner's catastrophic plate tectonics theory. He has a very comprehensive explanation of how this could happen. I've read some secular theories about that sound completely crazy about how, maybe this other planet hit the Earth a long time ago and buried itself in the core. And it's like, okay, but, that has to happen before there's life on Earth, right? So it would kill everything. It just doesn't work. The second one is thin lava flows record rapid polarity reversals in the magnetic field, which Humphreys looked for because of Baumgartner's theory, that the cold spots near the Earth's core would cause these polarity reversals, which secularists can't explain. And he made this prediction that there'd be evidence of rapid polarity reversals, which is also evidence of rapid seafloor spreading. Because if the polarity reversals are occurring rapidly, that means the seafloor reversals recorded in the seafloor are also occurring rapidly, and that is evidence of rapid plate tectonics. Okay. And then on top of that, Humphreys made additional predictions about the magnetic field strengths of other planets that hadn't been measured yet. And of course, his theory accords well with the known planetary magnetic fields as well. Okay, I don't have time to go through all this, so I'm going to skip this. But just know that there are a lot of things that catastrophic plate tectonics explains on the young Earth view, including a lot of things that I've heard before people say, well, they can't explain this, okay? All right, my number 2 is soft tissue and dinosaur bones, and you have had Brian Thomas on your channel recently. Great guy. I've seen him speak in person. He's an old high school teacher, so he knows how to keep a presentation interesting and fun. But in general, there is soft tissue in dinosaur bones, especially proteins like collagen. And Thomas has done a lot of work showing that this is, in fact, collagen in these dinosaur bones with different kinds of detection methods, including some really cool ones involving the twisting of the polarity of light and all kinds of interesting stuff. But he did his PhD on this in paleobiochemistry. And there are well over 100 studies published in the mainstream secular literature now on this. This is well accounted for in the mainstream literature. So this is not something that critics can deny is there. All of this protein should decay in less than 1 million years, according to bench studies that Thomas is an expert in, and the Arrhenius equation that they use to model this. Okay, which this is one of the things that I recently had a conversation with a friend of mine who's a college student. And when I explained this about the Arrhenius equation, he was like, oh yeah, we're studying that in chemistry. And the Arrhenius equation is about reaction kinetics. And what people don't realize is that there are chemical reactions that occur over a very, very long time. They don't just occur in a few seconds in a beaker in a lab in front of you, right? They can occur, degradation reactions can occur over a very long time, and the Arrhenius equation still applies there. And so what they do is they study the degradation of proteins like collagen and other biomatter in conditions of higher temperatures, and then they use the Arrhenius equation to calculate it out for lower temperatures over long periods of time, and have shown that the maximum amount it could last is 1 million years. Now, the person who discovered this is Mary Schweitzer. She's she used to be a young Earth creationist, but she's a Christian evolutionist now. And she even had trouble getting this published originally because people didn't believe her. But eventually she got it published and has taken credit for this. Now, later on, a young Earth creationist named Mark Armitage also found soft tissue in a Triceratops horn. And as soon as he published it, he was fired from his university. He was some kind of associate professor. So whenever a young Earth creationist comes up with evidence for a young Earth, you get fired. But when you're an evolutionist and can be trusted to toe the evolutionist line, you get credit for it. That's how this works today. But Mark Armitage he's got some independent funding, and he's got his own microscopy lab where he publishes work in the mainstream literature on this still. So he's doing okay. That's called I believe it's called the soft tissue dinosaur lab or something like that. He has his website. Now, Mary Schweitzer has claimed that the existence of iron coming from heme in your blood cells, your red blood cells, can preserve these soft tissues for much longer by iron-mediated cross-linking of proteins and other things. But last time I saw Dr. Thomas, he gave me a paper of a study where they did this thing. I think we were accused by Creaky Blinders of not knowing how science works. But I do think I remember something about experiments being important in science. And so Thomas noticed that, hey, there's this experiment somebody did about this decaying collagen in the presence of iron. And it turns out that collagen actually decays faster in the presence of iron than without. That's what happens when you do experiments. Sometimes it messes up your nice little theory. But anyway, this is a very strong evidence for young Earth. So this is my number 2, or at least this is strong evidence for young fossils, right? Which in turn is evidence that the layers that they're in are not that old. All right. How am I doing on time here? Okay. Has it been an hour already? Or no, this is only half an hour. Okay. Anisotropic synchrony convention. This is an astronomical model by an astrophysicist named Jason Lisle, who very recently made 3 predictions about the results of the James Webb Space Telescope. This was in 2022 when this came out, and Lisle made this
Ben, I just wanted to say, take your time, brother. You're doing an excellent job, and I don't want you to feel like you have to rush through your next few points. I like how detailed you are, so no rush at all, Ben.
Okay. This will be quicker, though. I think I might finish within an hour, so I don't have as much for these, so I'll try to slow down. So in late 2021, Jason Lisle knew that the results from James Webb were going to be coming out, and he made these 3 predictions. Okay. Now, I can take some time and explain why these are predictions of at least a skeptic of the Big Bang model. Some of them are not necessarily young universe, but they are predictions you would make if you did not believe the Big Bang model. Okay, so on the Big Bang model, they have this model of what they call stellar evolution. And it's kind of funny because ever since the James Webb Space Telescope has disconfirmed this model of stellar evolution, they've been claiming that this has nothing to do with the Big Bang model, which is totally false and bogus. because you would not need this particular model of stellar evolution unless you believed in the Big Bang. Why? Because this model of stellar evolution is entirely based on the fact that the Big Bang only gives you the first 3 elements on the periodic table. That is the lightest 3 elements of hydrogen, helium, and tiny amounts of lithium. That's 1, 2, 3 protons in the nucleus. Okay. The Big Bang model is predicted to only give you those light elements, and yet we have many heavier elements in evidence. So they have to explain where these heavier elements come from, only because they believe the Big Bang model. Okay, so remember that when people tell you that the stellar evolution model that has been disconfirmed by James Webb is not part of the Big Bang model. It absolutely is. Okay, so one of these predictions, that's the third one, is that Lyell thought at these higher redshifts, which means a farther distance away, according to something called the Hubble law, which Jason Lyell and nobody else is disputing. Okay, the Hubble law simply says that redshift is proportional to distance away from us. Okay, so stars that are farther away are a higher redshift, and that's pretty consistent. Okay. And Lyell has his own explanation for that got him some criticism from Luke Barnes, which we'll talk about a little bit. But according to the Big Bang model, if you see stars at higher redshifts, that means farther away, but it also to them means farther back in time, closer to the time of the Big Bang itself. In fact, they were hoping to see as close to the Big Bang as 300 to 400 million years after the Big Bang. Okay, and at that point, you should be seeing young stars on the Big Bang model. You should be seeing young galaxies. Galaxies, there should be much fewer of them. They should be showing signs of youth, which means they don't have what the secularists think are mature structures like spiral arms and things like that. You shouldn't see that because these galaxies have just formed. They're brand new galaxies. And in fact, this was one of the motivations behind doing the James Webb Telescope in the first place, was to try and see farther back so that we could see the early quote unquote universe. Okay. And Lyell simply predicted that you will see plenty of galaxies at higher redshifts. In fact, you should see the same amount as we see everywhere else. He predicted that you should see fully formed galaxies at higher redshifts, so mature galaxies. Okay, and you should see stars with heavy elements in them. Okay, because farther back in time, according to the Big Bang model, they shouldn't have these heavy elements. They're called population 3 stars, which are theorized to go supernova after they undergo fusion. And fusion would create heavier elements inside these population 3 stars. Then they go supernova and they spread their heavy elements around. Then it recondenses into population 2 stars, which undergoes fusion again, creating even more heavy elements. And then they explode and then form population 1 stars like our sun. Okay. And so they predict that you should be able to see population 3 stars in the early universe, which they think they should see at high redshifts. And these stars should only have the elements that were available from the Big Bang directly. That means 1, 2, 3, hydrogen, helium, lithium. Okay, and so Lyell predicted you won't see just those elements. You'll see heavier elements in those stars at high redshifts. And of course, the Big Bang expectations were all refuted, disconfirmed by James Webb. They expected galaxies would be 0 around redshift 14. We now know that is not the case. They expected at lesser redshifts than 14, we would see few low-mass galaxies in the process of formation, that is young galaxies with spiral and elliptical formations and no heavy elements. Okay, so all those were refuted by the evidence. Okay, but did Jason Lyell get any credit for this? No. Did he even get mentioned in the secular community? No. In fact, they went around going after a guy named Eric Lerner, whose big deal is an alternate explanation of the redshift. And in fact, most defenders of the Big Bang claimed that, well, this is actually a confirmation of the Big Bang theory because it follows the Hubble law, which no one on the younger side was disputing. And they said, well, if it confirms the Big Bang model because the Hubble law is confirmed, but then they claim that the stellar evolution model is not actually part of the Big Bang when it absolutely is. It's much more related to the Big Bang theory than the Hubble law is. But that's how spin happens in the scientific community. All right, so I talked about this last time I was on here. I just wanted to show that I have engaged educated PhD astrophysicists on this in public. This is a gal named Sarah Salviander. She's a theistic evolutionist, a Christian, I believe. And she posted a cute little post trying to engagement farm about how long should it take light to get to Earth from the sun? And it was a poll. So she was trying to get people to click and say, ooh, I know, 8 minutes, you know. And so I said, ooh, this sounds like fun. So I went in and commented, hey, actually, you know that because of the relativity of simultaneity, the time it takes for light to travel in one direction is based on your timing convention, right? And she hemmed and hawed for a while. And then finally, I just said, Sarah, you're a astrophysicist. I believe that you have a PhD in this. That means you know exactly what I am talking about, don't you? She then blocked me and posted this. And I want you to focus on the second and third sentences. I'm going to read them. In a research paper, this means a peer-reviewed journal article, I would be forced to tell the truth. To say it's an arbitrary choice because absolute simultaneity doesn't exist in the relativistic framework. Technically, the one-way speed of light depends on the synchronization choice, and there's no way to prove it's the right one. She's, of course, correct about this, and then she claimed that I did something wrong in the conversation and blocked me anyway. This is what happens when you're right as a young Earth creationist. You don't get recognized, you get excluded and marginalized. And she should say this because Albert Einstein himself said this, and this is credit to Jason Lisle for giving this quote in his book, The Physics of Einstein. That light requires the same time to traverse the path A to M as for the path B to M, that's just light traveling in one direction, is in reality neither a supposition nor a hypothesis about the physical nature of light. I want you to remember that phrase. It is not a claim about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. That just means, how do you tell when two events happen at the same time? The only way to do that is to make an arbitrary choice about what the one-way speed of light is. This is Einstein saying this. And of course, Jason Lisle comes to this conclusion, which is correct, that there can be no distant starlight problem for a young universe. There never has been. Now, briefly, I guess I didn't explain the problem. Briefly, the claim is made that because we can see light from distant stars that are billions of light years away in some cases, that means it must have taken billions of years for the light to get here, and that disproves a young Earth. Okay? Now, I'll go over Lisle's response to that in a second. But I just wanted to show you another response to this. This is Luke Barnes. He is famous. He's a Christian, I believe some kind of theistic evolutionist, old earther. He's a Christian who is famous for his work on the fine-tuning argument. So he makes arguments for the existence of God from science routinely. But of course, he's a critic of young Earth. And this is an article he published in the Answers Research Journal. This is the last paragraph of the article. Arguing with one of Lisle's other ideas about the explanation for the redshift. Lisle thinks that the redshift is not due to the expansion of space itself. He thinks it is due to stars simply moving away from each other within a non-expanding three-dimensional or four-dimensional space. Okay, so that's what he calls the Doppler model here, and the standard model is space itself is expanding. Okay. And when I first read this from Barnes, I laughed, and I'm not sure people will get why this is funny, but to me, this sounds like Barnes kind of fuming because he can't refute the anisotropic synchrony convention, which we'll get into. The only difference is a change of coordinates, which aren't physically observable. Yeah. The finite speed of light will make the universe appear to be billions of years old anyway. So supporting the first while criticizing the second does nothing to solve the starlight and time problem, which Lyle is not trying to do with this model. He's simply trying to explain how the redshift happens. Lyle proposes to solve this problem, this other problem, with the anisotropic synchrony convention, which implies that we see galaxies as they are now. Now is a timing convention, notice, regardless of how far away they are. This gives the model enough freedom that any observed population of galaxies is consistent with the young universe. In that case, one might as well attach the convention to the Big Bang model and be done with it. I love this because it's almost like Barnes is admitting that he cannot refute the ASC. And so he's saying, Lyle, why don't you just use your ASC and be done with it? Why do you have to do science beyond that? I'm sorry if that's not funny to people, but it's funny to me. So I thought I'd share it. I tried to find any articles refuting the ASC from Barnes, and I couldn't find them, by the way. So just take that for what it is. All right, now I'm going to try and explain the ASC in terms that anybody who's taken high school algebra can understand, okay? This is a two-dimensional coordinate system, or Cartesian coordinate system, okay? The x-axis is horizontal, the y-axis is vertical, and I should have got one that had numbers on it, but at each point, there's a zero. Where the y-axis crosses the x-axis is the 0 point for the x-axis. It's also the 0 point for the y-axis. So you see the point there is 0 and 0 for x and y coordinates. And then, of course, as you go one higher unit on the x-axis, that would be 1, 0, and 2, 0, and so on. And then the same thing with the y-axis. Okay. Now, what Lyle says is that the ASC and the standard model, which we'll talk about, are just coordinate systems, okay? Now, what is a Cartesian coordinate system? Is there any physical reality to it? The answer is no. This is a mental abstraction that we overlay on top of a two-dimensional surface to accomplish tasks with it, like a map. So let's say the point 0, 0 is my house, where I live. And let's say the green point, 2, 3, is the greatest college football stadium of all time, Memorial Stadium, through these gates past the greatest fans in all of college football. And since I have a ticket to the great Nebraska Cornhuskers playing the inferior Northwestern Wildcats on Saturday, I will be traversing the distance between the 0, 0 point to the 2, 3 point on Saturday morning. So it behooves me to know what this distance is and how to traverse it. So in this sort of made up thought experiment, what I want to do is draw a line between 0, 0 and 2, 3 on this little map. And that is called an interval. But the interesting thing about overlaying this Cartesian coordinate system on this map is that the coordinate system itself is not physically real. And I want you to remember what Einstein said about the one-way speed of light. It is not a hypothesis about the physical nature of light. And it doesn't say anything about what is physically real about the one-way speed of light. Okay? Like that, this coordinate system is overlaid. It's a mental abstraction that we place on a real system to try and figure stuff out about it. Okay? Like the distance between 2 points. To show that it's not real, I want to show you how physicists do something very simple called a transformation, where they change the coordinate system to a different coordinate system. Okay, that's called a transformation. So what I want you to imagine in your heads is move the origin point, which is the 0, 0 point, 1 unit to the left. Okay, so all that needs to happen is the y-axis moves 1 unit to the left. Okay. But importantly, the purple and green points, my place and the great Memorial Stadium, stay in the same location. Okay, so they don't move with the coordinate system because they're real. The coordinate system is not real. Okay, so I'm just going to arbitrarily shift the coordinate system one move to the left. Well, what would the new coordinates be for the purple and green points? Well, originally the point is 0, 0 for my place. But if you move it 1 unit to the left, it is now at position 1 on the x-axis, though it's still at 0 on the y-axis. And that is a transformation. In the first coordinate system, my coordinates are 0, 0. In the second coordinate system, my coordinates are now 1, 0. The numbers have changed, but my physical position is still the same. Why? Because I switched to a new coordinate system. I did a transformation. Likewise, the position of the great and hallowed ground of Memorial Stadium has gone from 2, 3 to 3, 3. And you'll notice this is the same mathematical operation that was performed on the other point. All I did was add 1 to the x coordinate. Okay? So you can actually perform this type of transformation without even using a graph, because all you have to do is use a mathematical operation to change each coordinate by a certain number. And that's called a transformation. Okay? So you can use any arbitrary coordinate system you want, and as long as you do the transformation correctly, the interval between the 2 points will remain the same. Okay? What about in 3 dimensions? Well, in 3 dimensions, it's very simple. You just add another coordinate, right? And you can imagine there's a z-axis coming out at you from the screen. Okay? And so the same thing, though, is true of 3-dimensional coordinate systems. All you have to do to perform a transformation is a mathematical operation that changes the coordinates by a set amount, and you get a correct transformation. Now, there is no objectively correct coordinate system. I can choose whatever I want the origin point, the 0, 0, or in this case, 0, 0, 0 point to be based on my needs. So I can put the origin point at my location just because it makes the math easier when I want to calculate the distance to the great Memorial Stadium. Okay? Or I can do it any way I want, right? I can put it at this new position on the point 1 unit to the right on the x-axis or whatever. It doesn't matter because it's not physically real. The origin point is an arbitrary choice of the will, as Einstein put it. Okay? What about 4 dimensions? Well, it turns out you can't actually visualize 4 dimensions on a graph. That is actually, nobody can do that. Nobody knows how that works. In fact, there's a funny story. There's a show called The Orville with Seth MacFarlane. It's a spoof of Star Trek. There's a character in that show who is supposed to be some super genius because she can visualize 4-dimensional objects, right? But it's supposed to be awe-inspiring because nobody can do that. Like she's some kind of one-of-a-kind genius. But the nice thing about increasing dimensions is you can still do transformations on them. You can still do the same exact mathematics with 4 coordinates instead of 3 or 2. It makes no difference how many dimensions you use. So you can still do the math. Okay? Now, relativity famously utilizes 4 dimensions. It says time is just another dimension, like the 3 spatial dimensions represented by x, y, and z, or width, height, and depth. Okay? And so what Einstein said is that if we do this, right, if we model the geometry of the universe in 4 dimensions with time as a 4th dimension, we can perform these same kinds of transformations. Now it's much more complicated than this, what I'm showing you here in relativity, but the concept is similar. And like in 2 dimensions and 3 dimensions, there are free parameters in the relativistic coordinate system. And Einstein told us what one of those free parameters is. It's the one-way speed of light. Okay? So understand that when Lyell makes his argument about the ASC, the main point that he is making is that the one-way speed of light is a free parameter in a coordinate system. There is no physical reality to the one-way speed of light under relativity theory. Okay? That's literally what Einstein said in the quote that I gave you. It means that according to relativity, we cannot say there is anything real about the one-way speed of light in nature. Okay? Now, if you have a problem with that, join the club. That is hard to make sense of. Okay? But you don't have a problem with young earth creationism. You have a problem with Einstein and relativity theory. Okay? And you need to be honest about that. This is not a scientific problem with young earth creationism. This is a problem that people have with relativity theory and how counterintuitive it is. Okay? So if you think this is a scientific problem, the distant starlight problem for young earth, if you think this is a problem for young earth creationism, it's not. It's a problem that you have with our best scientific theories, our best physical theories. And you need to be honest about that and not blame us for it. Okay? That's all Lyle is saying. Okay? Lots of people have problems with relativity theory. In fact, there are many physicists who are trying to build alternative models. One is called MOND, Modified Newtonian Dynamics, where they're trying to adapt Newtonian mechanics to be as accurate as Einstein's theory. But unfortunately, what they're finding out is the way to get it more accurate is to make it more relativistic. So I'm not sure that's going to work in the end. But anyway, this is not a problem with young earth creation. It never has been. It's a problem with people not liking our best scientific theory on these topics. Again, I want to emphasize this again, actually. It's just a coordinate system. It has no physical reality to it, and you can freely choose what the one-way speed of light is. It's just like the origin point. It can go anywhere, and it doesn't change the physical reality. And as long as you perform the transformation correctly in my illustration, as long as you do the math right, it's empirically equivalent to any other system, including Einstein's system, where he assumed, not proved, he assumed that the one-way speed of light is equal to the two-way speed of light. Now that's a good system. Even Lyle says he uses it frequently because the math is easier in certain situations. But Lyle points out that there are some situations where the ASC is actually easier to do math. He explains what they are in his book, Physics of Einstein. I don't remember, but he also makes the point that if on the fourth day of creation, God creates the sun, moon, and stars, okay, on the fourth day, and he creates them as signs to mark seasons and days and years, that means that the light from them has to be visible very quickly. Otherwise, they wouldn't be signs, right? And so Lyle argues that the ASC, the anisotropic synchrony convention, which models the one-way speed of light as though it were infinite because it is a free parameter, is consistent with the biblical account, meaning he thinks God used the ASC when he wrote, when he inspired Genesis 1, okay? Because God says that the lights were created on day 4 and were signs to mark seasons and days and years, which means they must have been also visible on day 4 or shortly after when man was created, okay? So he argues that the Bible uses the ASC convention. Now, that's not to say the ASC is correct, right? There's no correct about it. It's not a physical reality. It's just a coordinate system, an abstraction that we lay over physical reality to do math in it and try to figure stuff out, how things work, okay? Doesn't matter which one you use. They're all equivalent. All right, number 4 on top 5. We're getting close here. Helium in zircons. This has something to do with a major young earth creationist study called the RATE study. They had about $1 million to do this study, which is a lot of money for a young earth creationist. It's not a whole lot of money in the secular community. But when we have money, we take and opportunities like what Baumgartner had at Los Alamos, we often tend to take advantage of them. So they had $1 million to do this study, and it was noticed before the study that there's a lot of helium in these zircon crystals. Zircon is a kind of quartz, And if you don't know this, we actually get helium from the rocks. We mine them. We mine helium out of the rock to get it. And so there's actually a tradition at Cornhusker football games to release helium-filled balloons when they score their first touchdown or their first points. Nobody's really sure which one it is anymore, but it used to be first touchdown when I was young. But then there was a shortage of helium several years ago, and so they stopped doing that for a while. But it turns out there's a huge facility somewhere near Houston, Texas, that mines helium out of the rocks there. And the reason is because helium is such a light element that it doesn't stick around in the atmosphere. It actually escapes the Earth's atmosphere and leaves. So you can't get it out of the air. You have to mine it out of rocks. Now, why is there helium, this super light element, trapped in rocks? Well, it turns out when radioactive decay occurs of radioactive elements, which are used in radiometric dating, where the old earthers get their old ages for rock layers. One process that it undergoes is called alpha decay. Alpha decay results in alpha particles, which are... And so as soon as alpha decay happens, this helium nucleus gets spit out of the heavier element, right, as part of the decay process. And it picks up electrons from the environment and becomes a helium atom. But because it's in solid rock, it gets trapped inside the crystal structure of the rock. Okay? Now, there's a certain amount of helium that would be created by a certain amount of radioactive decay, right? It's a certain amount. And then there is a certain rate at which helium diffuses out of the rock. And if the rock is as old as the old agers claim it is, all the helium should be gone from those rocks based on the helium diffusion rate that the rate study measured. Okay, they hired an independent lab to do this. It was a blind test. They didn't tell them what they wanted or what they were doing. They just said, here's these rock samples, okay, measure the rate at which helium diffuses out of the rock. Okay, and it turns out that the rate at which helium diffuses out of the rock, the amount of helium we would expect to be there because of the decay versus the amount that's actually there still, is consistent with the young Earth time scale. Okay, it's very consistent. It has a large error bar, but it's got 6,000 years right in the middle. Okay, a very strong evidence of a young Earth. And so many young Earth creationists used to argue that maybe there wasn't, that these radioactive decay cascades didn't start out at the very top. They didn't start out with the heaviest element and go all the way down. They started out somewhere in the middle, and that accounts for why it looks old but isn't. But because of the rate study, most young Earthers now argue and believe that actually all of this radioactive decay has occurred. We just think there must have been a period at which it occurred much faster in the past. And the rate study suggested about 600 million years worth of decay occurred during the flood, and the rest occurred during creation week. Okay, but we don't have a good model for how that would have happened. All we have is this little thing called evidence, which I don't know. I don't know. As a young Earth creationist, I don't know anything about science, but I thought that maybe evidence trumps theory. Maybe, but I'm obviously wrong about that because I'm a young Earther. But we say we have evidence that these rocks are actually young, and otherwise they would not have all this helium in them. The helium should have diffused out by now. All right, number 5, and this is, I think, one of Donnie's favorites. Carbon-14 in diamonds, coal, fossils, and literally everything else with carbon in it. Okay, so the carbon cycle has to do with plants. They get their carbon from CO2 in the atmosphere, carbon dioxide. And carbon-14 is an isotope, a radioactive isotope of carbon. Most carbon, the vast majority of it is carbon-12. So carbon-14 has 2 extra neutrons in it. And these neutrons will decay into, I believe, nitrogen or something. A proton will leave as part of this decay as well, I think. I don't remember that specifically, but carbon-14 is radioactive, carbon-12 is not. And so carbon-14 will decay over time, whereas carbon-12 generally doesn't. Okay, and so what happens is we think there's this ratio of carbon-14 to carbon-12 in the carbon dioxide in the atmosphere, because carbon-14 is sort of created in the atmosphere by certain processes. And then this carbon gets taken up into plants. Plants get eaten by animals, and so this carbon-14 goes everywhere. It gets in all the living things, anything with carbon in it. It gets exchanged. And so we think we can tell by the ratio of carbon-14 to carbon-12 how old things are, and that is called carbon dating. Now, the carbon-14 half-life is 5,730 years. That just means how long it takes for half of the carbon-14 to be gone compared to the original sample. In less than 100,000 years, all detectable carbon-14 should be gone completely. Unfortunately, for the old agers, there are detectable levels of carbon-14 in basically everything with carbon. That means coal, that means diamonds, fossils, and everything else, okay? Everything they've tested has detectable levels of carbon-14 in it. And that means they cannot be more than 100,000 years old. Now, secularists have tried to claim that there is errors in the machines that measure these things, that detectable levels has been calibrated wrong or something. I used to work with a lot of very complicated machines like this. And it is a little tricky sometimes to determine what a detectable level is at very low levels when you're using a machine to measure things. But this has been a very consistent finding, okay? And I trust the people who are running these machines to know what they're doing. And the carbon-14 in these samples are above the detection level. It is not noise, it is statistically significant carbon-14 detected. Okay, but it is low, and we would expect it to be low because the half-life of carbon is pretty short. Okay, I'm basically done. I have some honorable mentions here if we want to talk about those, but we can move on to the video if you guys want.
Ben, this presentation was so good. I think we're going to have to clip it out. Actually, can you full screen those honorable mentions? Because, sure. Okay, you made many excellent points, but I personally see the genetic evidence as not only limiting the age of species in age of humans. So your first two here, mitochondrial DNA and Y chromosome, overall genetic diversity in both of those uniparentally inherited DNA compartments is low, mutation rate is fast. We're looking at biblical time. You can't get a couple 100,000 years out of the amount of DNA diversity that we find in those chromosomes in light of the fast mutation rate. And feel free to touch on that. But the reason why I'm pointing this out is because even with genetic entropy, okay, so deleterious mutation accumulation puts shelf lives on genomes. The mutation rate is far too fast. Selection can't see most mutations. They're nearly neutral. They're subject to drift, so they spread, as we know. Now, as Rob Carter has said before, if species cannot persist for millions of years into the future, Ben, they could not have persisted for millions of years into the past. And why I think genetic entropy not only limits the age of species, but also the age of the Earth, is because we have extinct biology. So if genetic entropy limits how long biology could be on the Earth based on what we know today, but yet we have extinct biology through fossils, billions of fossils, represented all throughout the so-called geologic column going back 500 million years. Well, since we find extinct biology, we find fossils in the rock strata, well, they're obviously correlated. So by definition, if the biological organisms have to be young that are found there, then doesn't the rock strata also have to be young? I mean, how can you have the biology young, but then the rock strata that we find them in old? I mean, they would both have to be young. And so I think in a way, the genetic data, and the reason why I'm saying this, Ben, is because I've seen many old earthers, brother, they concede. They say, okay, well, the genetic evidence means humans go back maybe 6,000 years. Okay, but wait a minute. You're still dodging the fact that we have fossil representation all throughout the geologic rock strata. Ben, I'm curious to see your thoughts on that, brother.
I hadn't thought about it that way before. What I have thought about that's a little probably related is something that Nathaniel Jeanson pointed out in his book, Replacing Darwin. And that is that the rate of speciation is too fast.
Right.
For an old Earth. And that's also related to the extinction rate too, because the number of new species versus how many die off is kind of related. Well, I was thinking about something else too. I lost the thought, but I wanted to say something about mitochondrial and Y chromosomal DNA that I think a lot of people miss. You mentioned uniparental, right? That's an important concept, and because it makes it much easier to model trees of Y chromosomes and mitochondrial DNA.
Right.
Joshua Swamidas, whom I've interacted with a bit, he insists on using autosomal DNA for these types of models. Why? Because he can play around with the assumptions a whole bunch. Because it's much more complicated because of genetic recombination. Okay, and so he has all these sophisticated models that show ancient, millions of years history based on the autosomal DNA. And meanwhile, creationists are just saying, man, why aren't you using the Y chromosome and mitochondrial DNA? It doesn't require all these assumptions that we don't know that they're right, So it's like, why use the worst possible model when you have a better one staring you in the face? It's because it shows a young biology.
Exactly. And, the fact that we see when it comes to biology, so many living fossils like coelacanth. Dr. John Sanford mentioned the horseshoe crab in his National Institutes for Health NIH presentation. And he basically argued that you can't really have living fossils in light of what we know about mutation accumulation, because these organisms, again, would not be able to survive for millions of years unchanged. Based on deleterious mutation accumulation, they should have degenerated to the point of extinction. And so because we find those representations going back millions and millions of years ago, 65 million years ago, roughly, to coelacanth, even more if you go to the origin of them, according to the evolutionary model. No, mutation accumulation puts shelf lives on genomes today, but also in the past. Those fossils are found all throughout the rock strata. And so I would argue that also shows that the rock strata itself has to be young, because that's where they're found in.
Yeah. Evolutionists never seem to pay the penalty for failed predictions like the coelacanth, do they? Right.
Yeah.
They can always, this thing went extinct because it's in these layers, but not higher layers. And then they find a live one. Oops.
Right. Yeah.
Like
oops. Well, typically they'll say, but they're not exactly the same as the fossil coelacanths. And it's like, well, even as creationists, we agree with change, adaptation, and morphological variation. So anybody can tell that coelacanth is coelacanth. It's the same thing, with maybe a little bit of variation in 4,500 years since the flood. I mean, is that really a good objection that they raise, Ben?
I mean, why did you call it a coelacanth?
Yeah, right. If it's so different, why even call it a living fossil?
Because it is a coelacanth,
Right.
I remembered what I was thinking about earlier. You know how evolutionists say that we're in the 6th mass extinction event?
Yes.
Right now?
Mm-hmm.
They think that because they measured the extinction rate of species today, and they think it's too fast to explain all the extinctions that have occurred in the past. So they think the extinction rate today is occurring way faster than it should be. And so they get all upset and be like, we're in the middle of an extinction event when actually it's probably just the normal rate
Right.
that has
Good
been
point.
happening forever. So, and then they accuse us of, ad hocness and all that stuff.
I've experienced this directly in debates where they'll say, oh, young earth creationists can't explain the amount of species that we see today coming off of the ark, originating from archetypes or ancestors 4,500 years ago. Then we'll show them examples. Dr. Nathaniel Jensen has done this, as you pointed out. We could show them bird species, mammals, reptiles, rabbits, lizards, you name it, snakes, and they're all in line based on known observed speciation rates and patterns. They're all perfectly in line with 4,500 years. And we'll show them that. For example, with bird species, there's somewhere between 12 and 18,000 bird species. We have a good idea as to the rate at which new species form. We've seen on the Galapagos Islands a new finch species. Nathaniel Jensen ran the numbers. And basically, if birds go back millions of years ago to an origin with theropod-like dinosaurs, let's say, even with extinction rates, we should be finding tens of thousands to 100,000 bird species. Yet we have just under 20,000. But then they, in my opinion, dodge, because then they go to, as you said, Ben, extinction rates. Well, you're not considering extinction rates. Well, what is it? Are there too many species for us young earth creationists or not? Because once we show you that there's not, then they say, well, you got to consider all these massive extinction events over millions of years. So it's like they want their cake and eat it too, in my opinion. Ben, what do you think?
Yeah, I mean, I don't understand why they invent these mass extinction events unless the data is not consistent with Darwinian gradualism.
So I found an argument that was made a while ago. I believe it was on LPP's channel, and it was with Sal Cordova and Dr. Carter, and it was about racemization dating. And apparently, and you can help me develop this because I don't remember exactly how it went, but something about living organisms have like right-handed and left-handed racemic ratio in the proteins. And as when something dies, they switch, maybe they turn right-handed. And so when we find proteins in the geological strata, it should correspond with their dates, meaning that the racemization should have switched over the further down you go, and they don't. You familiar with that argument?
Yeah, you got it a little bit wrong. Can I stop? Am I not sharing my screen anymore?
Do you want to share it, or do you want to stop?
I kind of want to see you guys.
Okay, yeah. Let's remove it.
Staring at a PowerPoint here. What?
I forgot a little bit how the argument went. So it was a few years ago. But...
Yeah. So this is about molecules that have what's called a stereo center. Yeah. And what that means is just their molecules can be similar to your right and left hand. That I have the same number of fingers, the same number of thumbs, and they're connected to each other the same way, but they're mirror images of each other. Okay, so molecules can be structured that way too. So you can have right-handed molecules and left-handed molecules. And the thing about biology is that in biology, all our amino acids are, I believe, left-handed by the old system. There's two different systems. I had to learn them both in college. The new system is called R and S, and I don't remember the name for it, but all the amino acids and pretty much everything else has to be left-handed. If it's not left-handed, it messes up our biochemistry. Okay, so this is a big mystery. Because if you just make these molecules in like in a lab, like in a beaker, they will come out in what's called a racemic solution, which means 50% one enantiomer and 50% the other enantiomer. That's what it's called when they're stereoisomers. Okay, so they're called enantiomers. They're the same basic molecule, but they're the mirror image of each other. Okay, and so a naturally occurring chemical reaction like abiogenesis, for example, would result in a racemic mixture, meaning 50-50. But in our bodies, it has to be 100% one way, or it doesn't work. Okay. And so what Cordova and who's the other guy? Carter, we're probably talking
Dr.
about.
Carter, yeah. It wasn't Rob Carter. It was
James Carter. James
Carter. That's right.
I don't know him. Okay. What they might have been talking about is after organisms die, what will happen over time is the molecules in your body, which start out 100% left-handed, will slowly over time racemize, meaning half of the molecules after a long period of time will end up the other enantiomer. Just naturally they'll switch, and because they're so close chemically that they can switch between them. So they may have been talking about a way to date dead bodies with that.
Anything within the geological column, they're saying, as the layers are supposed to be interpreted as being indicative of age, then so too should these ratios that we find in them. However, they don't. We don't find the ratios lining up with the assigned ages of the stratigraphical layers. And so they aren't saying that you can use that to show, to put an age on it. It's just to show that it's not consistent. And so then you would have to pick, are you going to go with the higher quality science, because we can measure the rate at which thank you for correcting me, they go from left-handed to left and right-handed as things die. So you can go with that, which is a higher quality line to date the geological layers to show that they've all been laid down at the same time or around the same time. Or you can go with the layers themselves. Which is what the evolutionist is going to want to do.
My guess is that they found some kind of evidence that in some of these fossils that are supposed to be really old, some of the soft tissue that remains is not racemized yet.
Yeah.
So I mean, it hasn't reached 50-50 enantiomeric ratio yet, and so that means it's probably not super old, basically.
That's right. I'll send you the stream, but that's similar to the argument that Donny was making, where we have that as an argument as well.
Yeah, that's interesting. I hadn't heard that one.
Well, and it's the same thing with the piece of evidence that you pointed to, one of my favorites as well, Ben, with the dinosaur soft tissue and collagen and biological material found in dinosaur fossils going back 65 million years at least. And since those dinosaur fossils are found in rock strata that are claimed to be millions of years old, but the fact that we find those preserved biomaterials, that tells us not only that the fossils are young, the biology is young, but also the rock strata that they're found in is young. But I wanted you, Ben, if you could, because I really enjoyed your section there on the ASC model. And it's established that the distant starlight problem has been solved. It's been answered. You cracked me up, brother, with Luke Barnes. And so, Luke basically conceded. So I do appreciate Luke Barnes conceding the debate for us. And nobody has adequately or sufficiently addressed the ASC model. Usually it's misunderstandings or straw man arguments. Maybe we can get into some of that. But here in the live chat, we've got Jam and other critics. They keep pointing to the so-called distant starlight challenge, even though you addressed it thoroughly, not understanding. And maybe here's my notes on it from based on what I've learned from Dr. Lyle and yourself and Dr. Hartnett and so on and so forth. And so perhaps we can slightly reiterate some of these points to the critics. Dr. Jason Lyle's ASC model shows that the so-called distant starlight problem is really about how we measure time, not how light travels. The one-way speed of light can't be measured, only the round trip can. So if light travels instantaneously towards Earth, as the Bible may imply, basically we're seeing light from the most distant stars and galaxies in real time as it is. We're seeing deep space in real time, as I have here on the slide. But here's the most important point, because Jam here has said he's waiting for an explanation, Ben, that is consistent with known physics or doesn't contradict with known physics. But that's the whole point of this. And correct me if I'm wrong, Ben, you understand this model better than I do. It is fully consistent with the physics of Einstein and removes the starlight problem entirely, even if it may be counterintuitive, where it's hard for us to really fathom or understand why, but it really is consistent with the physics of Einstein. Is that right, Ben?
Yeah, and what I would ask Jam is, which clock are you measuring 7,000 years on?
So there's an excellent upload by a YouTube channel called Veritasium on this, and I believe the upload is called here on YouTube, "Why No One Knows the One-Way Speed of Light," and they break it down. It's a very difficult thing to understand at first, but can I try to give a quick analogy that's pretty simple?
Sure. Yeah.
So let's say that you live on a street and there's a store at the end of your street, and you walk to the store and back. You forgot your wallet. You walk there, you get your wallet, and you come back. Round trip, it takes an hour. You like to walk. It could be that it was 30 minutes each direction. That's typical. That makes the math easy. But it could be that it was uphill one way and downhill on the back. It could be that it was 40 minutes one way and 20 minutes the other way back. As long as the round trip doesn't change, then the one-way speed of light doesn't matter. That can fluctuate. And so there's two separate conventions, the isotropic and the anisotropic convention. And as long as you both agree on the round trip, which is fairly well established, then one model can posit that the half distance is 50%. The other one can be any increment, 49 and 51, all the way from 1 to 99. It doesn't really matter, as long as at the end you get 100% of the round trip.
I mean, yeah, that would describe how you could, there's literally an infinite number of conventions that you could use for the one-way speed of light that would all be empirically equivalent. And what I mean by empirically equivalent is there's no discriminating evidence. I like that phrase, Donnie. I'm going to use that more often. There's no evidence that is even possible to discriminate between different conventions for the one-way speed. So the physical evidence will look the same no matter what you assume the one-way speed of light to be, as long as you're doing the math correctly, which most critics don't do the math correctly. That's the mistake that Phil Dennis made, is he used equations from his physics textbook and said, see, look, Lyle, you're wrong. And Lyle just pointed out that the equations that he was using already incorporate the Einstein synchrony convention. They already assume and were derived from this assumption that the one-way speed of light equals the two-way speed. And by the way, the two-way speed of light is a physical constant. It's called c. It doesn't change. In fact, the people who are in charge of these sorts of things, they have declared now that the one-way speed of light is actually just a constant and nobody can change it anymore, which is fine. But Lyell's anisotropic synchrony convention just models the one-way speed as infinite in the direction of an observer, and then directly away from an observer, it would be c divided by 2. And if you work that out, the two-way trip would be equal to c then. And then there's a trigonometric function for angles that are different from, directly towards an observer, directly away. And that's another thing people get wrong. Like, people say, well, if the one-way speed of light is infinite, we can look at, supernovas and we can see that light has traveled horizontally to our position as the observer in a certain amount of time, and therefore the one-way speed is not infinite. But the ASC doesn't model light traveling horizontally to the observer as infinite. It's according to a trigonometric function based on the angle away from directly towards us that it's going. Okay. They don't understand the model.
Well, that was the point, if I remember correctly, that Hugh Ross brought up against Jason Lyle in online debate, which was really good because it was more discussion focused. And Dr. Lyle did an excellent job and really showed that even someone as knowledgeable or educated as Dr. Hugh Ross really could not adequately address this model. And I think that was one of his objections. Hugh Ross's objections was the horizontal argument based on supernovas. And as you just said, no, Jason Lyle addressed it, and you just did as well.
Yeah. So back to Jam here.
Yeah, he just put this one up. So I'm curious, Ben, what would be the best way to respond?
The measuring time on Earth in any other reference frame. The problem is that people don't understand what's called the relativity of simultaneity. And this is the name of a chapter in Einstein's book on relativity theory. So I'd recommend reading it. I got it for 99 cents on Kindle. Okay, it's not hard. It's probably hard to read, but it's not hard to try at least. The relativity of simultaneity simply means that when you say that two events occur at the same time, how do you measure that in relativistic terms? If you take, so this is part of the problem with being unable to measure the one-way speed of light. The reason why you can't measure it is because you cannot synchronize clocks that are a distance apart from each other. On relativity, it's impossible. Why? Because the speed at which a clock ticks changes as it moves relative to another clock. Okay, so there's no way to separate two clocks without them becoming desynchronized. Okay, and so you can't have a system where you shoot light from one clock to a clock at a second location and know that the two clocks at point A and point B are synchronized. They're not. Okay, and so this is a problem when you're trying to make a claim like, let's just use the claim that people know is a little easier to deal with, and that's that light supposedly takes 8 minutes to get to Earth from the sun. Okay, so how do we know that it takes 8 minutes to get to the Earth from the sun? Well, when you say that, what you're doing is making a claim that there's such a thing as absolute time, right? Because there is 8 minutes of absolute time that has passed in the absolute time space that light has spent traveling from the sun to the Earth. But because of the relativity of simultaneity, there's no such thing as absolute time if relativity theory is true. Okay, so how do we know when by Earth's clock the light left the sun? Okay, we can't know that without synchronizing the two clocks, and relativity says that's not possible. Okay, so we don't have a time in the Earth's reference frame when the light left the sun. Okay, unless you assume what the one-way speed of light is. Remember what Einstein said. Okay, let me bring up this quote again. Where is it? See if I can. I don't remember where it is in my presentation. Here we go. We're getting closer. There we go. Okay. Einstein said that the one-way speed of light is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. In other words, I'm done. You have to arbitrarily pick a one-way speed of light in order to know which events are simultaneous or not. Okay, without doing that, you cannot do it. Okay, you have to just freely choose something, and this is why I talked about coordinate systems in my presentation. The choice of what the one-way speed of light is a free parameter, just like the choice of the origin point of a Cartesian coordinate system. I can put that 0, 0 point anywhere I want. I can put it at my house. I can put it at Memorial Stadium. I can put it at a house down the block from me. It doesn't matter. It doesn't change the physical reality of the system. I can use it no matter where the free choice of the origin point is. In relativity, the one-way speed of light is like the choice of the origin point of the Cartesian coordinate system. It is a free parameter. You can choose what it is. And once you choose what it is, now you have a definition of simultaneity based on your arbitrary choice. Okay? And so you cannot say that there is some physical reality to the one-way speed of light that is not based on an assumption.
Ben, I'm going through all the comments. Let's do one more on this, and then let's move to the video, because, well, firstly, your presentation was so good. Each point that you brought up was deserving of its own program, like the CPT point.
Yeah.
That final slide where you had everything listed, including the ice age and how it can explain the subsequent ice age. That'd be great as its own show. An entire show on the ASC model would be great. I know Sam and I have been looking to have a program on that for a while, but let's answer this to hopefully help people understand this model a little more. I know, again, it's counterintuitive. It's kind of hard to fully comprehend what's going on here as to why it's not a problem. But Tanya Brown is asking, why does the ASC only affect the light coming towards us?
Okay, you guys, I think Sam said before the show he's going to go see Jason Lyle soon, right?
Yeah, I'm going to see him on Sunday.
Yeah. The first time I saw Jason Lyle present this idea, I thought he was crazy. Okay. I saw it in a church too. Sunday morning, I went with my dad in Dallas, Texas, and I went and saw him present this, and I'm like, that makes no sense. Okay. But I studied it, and I studied the physics behind it. I read his book, The Physics of Einstein. Okay. And I understand it now. Okay. So what you said there, Tanya, why does the ASC only affect the light coming towards us? The ASC doesn't affect light at all. It's just a coordinate system. Okay. Remember when I was talking about the two-dimensional Cartesian coordinate system of the x-axis and the y-axis? When I use that on a real map, right, my choice of where the origin point goes does not affect reality at all. I can put it anywhere on the map, right? And reality doesn't change. Light does not change. It doesn't change by how you choose your coordinate system, okay? All that changes is the math, right? And as long as you do the math correctly, transformations between different coordinate systems, it will correctly model reality. If that's not what your question is about, then I don't know what it is about, and you need to word it better. Sorry.
All right, let's take another shot at this, and I'm gonna try to, because this is a difficult thing for even me to understand.
But it's important because it literally demolishes one of the number one challenges against the young Earth. So yeah, I think that's a good point, Sam. And so feel free, take another shot at it, brother.
So let's say that you are on the sun, or you are the sun, and you shine your light towards Earth, okay? It could be, and so that's a 16-minute round trip. We figured, depending on the model you use, the convention, 8 minutes here.
No, that would be the constant of the speed of light. The two-way speed would be the constant. Yeah.
Yeah. So according
if you're saying the light goes to Earth and back, I'm assuming, right?
Right. So that according to the isotropic model, it would be 8 minutes to Earth, 8 minutes back.
Right.
But the anisotropic model, as long as you still have 16 minutes round trip, it could get to Earth instantly and take 16 minutes to return. So in that way, it would affect us. Well, how would it affect us? Well, it's an abstract on one hand. That's what Ben was saying. So it doesn't in that way. But as far as us observing something in real time, it would affect us in that way. We could be observing the light in real time, but if we were to send that light back to the sun, it would take the full 16 minutes. As long as when you're at the sun, it takes 16 minutes to go back and forth. It doesn't really matter how long it takes each way to travel, as long as your round trip doesn't change. And so 8 minutes there, 8 minutes back, that's the isotropic model. Any increment, any adjustment you make, anything that's not 50-50, that would be, I know you're shaking your head. And I know why. I know why.
The question. We
I
already
think he's shaking his head at Jam.
Okay. But I understand.
I wasn't shaking my head at you, Sam.
Okay.
I was reading the question.
All right. But just to keep it simple, the anisotropic model would just say that it can be instant here, 16 back, or maybe 1 minute here and 15 back, or any increment that's not 50-50. And that's it. Nothing changes. The math doesn't change.
Your observations won't change either. That's what empirical equivalence means. You will see the same thing because the coordinate system you use does not affect reality. Okay?
Ben was nodding to what you were saying, but shaking his head to what Jam was saying. So he was trying to nod and shake his head both at the same time, and it created this kind of fusion head movement.
Yeah. It's I mean,
I seen that in where they do that?
Yeah.
If you're just trying to disagree because you hate that your only good argument, so you thought, is Starlight, and you're just like, no, they have a response, then yeah, it's going to be hard for you to understand. But if you realize that you're not actually arguing against us or Dr. Lyle, but Einstein himself, all Lyle did, he says, hey, look, I like what Einstein did. Let's apply it here. That's all he did. So you're not really arguing with anyone but Einstein, and you got to do better. I mean, but anyway.
Yeah, Phil Dennis likes to claim that Einstein didn't really say this, and that
I was going to ask you about Phil Dennis, actually.
Yeah.
What are your overall thought? Actually, but before you do give your overall summary on Phil Dennis's objections and criticisms to the ASC model, Jam, can you give a real quick response? I feel like you did address this though, Ben, with the supernova, but maybe I'm just not understanding it fully. So he's saying we observe binary stars, supernova, pulsars, all show light at normal speeds between objects. So between, is he referring to horizontal?
Usually pulsars comes up in the context of gravitational lensing. But I'm not 100% clear on what he means here, unless he means that light is traveling between two distant objects horizontal to us.
Yeah.
So we already answered this. The ASC model models light as being instantaneous only directly towards an observer. If we're the observer and we see, right, because we're observing this, right? We're observing light traveling between objects, right? We're observing light moving between a pulsar and another one, or whatever he's talking about. I'm not sure. That means the light is moving horizontal to us, not directly towards us. And I can show you the equation. I would have to go dig it up, but it's in Lyle's original paper. There's no excuse not to know this, right? It's a trigonometric function based on the angle at which the light is moving with respect to the observer. And it changes the value of the one-way speed depending on that angle. Okay, and Lyle has shown that this is empirically equivalent to the Einstein synchrony convention. So Lyle calls what you're calling the isotropic convention. He calls it the Einstein synchrony convention, which is just the assumption that the one-way speed is equal to the two-way speed, or C. So he calls it the ESC. So that's what I usually call it. But
yeah, I mean the ASC is as well. I'll ask him why he says that, because they both would be. It's just the one that Einstein used, the one that he preferred, right, because it's going to make the math a lot easier.
In his book, The Physics of Einstein, which you should read if you're interested in this stuff, Lyle explains all of this very well, and he says you can understand it with nothing more than high school algebra, and he's right about that. But in his book, he admits that he uses the ESC sometimes because it does make the math easier in certain situations. That's why you use conventions, right? You use one convention because it helps you do something a little easier. But he explains a couple situations where the ASC actually makes the math easier. So he will use it sometimes.
Ben, look at this. Lazarus Conley, appreciate it. He's saying, I'm pretty sure they've timed the speed of light plenty of times and continually gotten a constant speed in a vacuum. Did this with the Michelson-Morley experiment in the late 1800s, didn't they? What are your thoughts?
They've timed the two-way speed of light and found it to be a constant. And the reason why you can measure the two-way speed and not the one-way speed is because the only way to measure the one-way speed is to have two clocks that are apart from each other that are synchronized, which is impossible according to relativity. So what they do instead is they send the light out from one clock, it hits a mirror and reflects back and hits at the original clock. So now they can prove that this clock is itself, right? So it's synchronized with itself. So now they can get a time for the two-way speed of light. That's what they've measured in a vacuum or whatever. Now, the Michelson-Morley experiment, as far as I understand, it has nothing to do with this. I could be wrong about that. The Michelson-Morley experiment was used by a lot of people to argue that the ether doesn't exist.
Right. That's what I've seen it in context used for.
It probably is related to the speed of light somehow, but I don't know how it is. I would have to research it more. Or maybe this is just don't want to say this, maybe dumb question, but I don't know. I don't know.
Well, I don't know why people spend so much time trying to debunk it. I mean, as you pointed out, this convention is a valid choice. It's consistent with the physics of Einstein. But I've even heard Dr. Lyle point this part out, that it can't be falsified because it's simply a convention, not a measurable variable. So they're trying to falsify or refute something that you can't even. Would it be equivalent to basically trying to refute whether or not we're going to use kilometers versus miles? It's just a different convention, right?
Yeah, that's also a convention. I was trying to explain it in terms of a two-dimensional coordinate system, which maybe I failed. I don't know. But refuting the ASC or the ESC for that matter, or any other convention in between, would be like trying to say you're wrong to put the zero of your x-axis at this point, right? At my house. Like that's not wrong. It's not right either. It's just a convention. It's like I do it so I can use the coordinate system to try and measure the distance to Memorial Stadium to make sure I'm there before kickoff, it's not a physical reality. It's just a tool that we use to model certain things in nature, and it doesn't track with anything real. And I'm sorry if that sounds weird to you. It sounds weird to everybody, but this is where science is at right now. And if you talk to a real physicist, am I getting echo here?
Can you hear an echo?
I can. Yeah.
Let me try to mute.
No, you know what? Can you hear an echo now? Try.
Hello.
Any echo?
Nope.
Okay, we're good.
But yeah, this is why I tried to show the end of the conversation I had with that astrophysicist on Twitter named Sarah Salviander, because she just basically confirmed, right? She knows this is correct, and yet she was arguing with it anyway. Because even she, as a trained astrophysicist, doesn't like it. And she tried to give these other reasons why we use the ESC, but none of them are holding that the ESC is actually true. She said we use the ESC because it makes sense of other physics. We use the ESC because it just makes more sense to do it that way. But she said very clearly that if I were writing this up in a peer-reviewed journal article, I would be forced, her words, to admit that it's an arbitrary choice. Okay, so professional physicists know that Lyle is right about this.
And it got you blocked, brother, for preaching the truth.
Yep.
No refutation, just got you blocked. Well, okay. That was really good. And I appreciate the fact that we were able to address several of these comments. We're seeing light from the most distant reaches of the universe in real time. No distant starlight problem. Critics, you're just going to have to accept it, and we're going to move on. So
Back to the drawing board.
there we go. Exactly. Back to the drawing board like they usually have to go. So, okay, let's continue then. Ben, again, excellent presentation, brother. So good. Extremely detailed. Many points that I could bring up or reiterate for the next 10 hours, but we'll have to save that for future shows. So really good stuff. And let's continue here. It is probably good that you save the salt accumulation as an honorable mention, because you do make that point here. And then Creaky Blinder tries to refute it. And so we'll get that context here in the video itself. So, okay, gentlemen, here we go. If there's any echo or anything like that, just let me know and I can mute my mic directly from the mic itself.
I can't hear anything.
Yeah, I can't hear anything.
Oh, you're not hearing anything?
Hmm.
Okay. Let's see. Oh, you know what we're going to have to do? Okay. I'm going to have to keep this unmuted, the screen share part. But then once we start to talk again, we'll probably end up hearing an echo. So are you hearing an echo?
Not right
Not
now.
Okay.
from you. Now from me. Yeah.
Yeah. Okay. So once we talk again, I'll have to go in here and mute it. I don't know why StreamYard does that, but I'm the host, so me screen sharing is going to be a bit of an issue, but we'll get through it. So let me rewind it a little bit. And okay, here we go. If you're not hearing it, though, let me know.
This is the argument about salt concentration in the oceans, because that's really easy to explain.
Go on then, explain it.
That the rate at which salt accumulates in the oceans because of runoff from the continents, salt dissolves into rivers and runs off into the oceans. And so salt but when water evaporates from the surface of the ocean, the salt doesn't evaporate. So it leaves the salt in the ocean and the water cycle continues.
Are you stuck at $10,000 to $50,000 per month with your digital marketing agency, working 60 plus hours per week?
Okay.
But isn't that just based on the assumption that salt goes in but never comes back out, which is wrong? Because in reality, the ocean is in a constant state of dynamic equilibrium. Salt is constantly being removed through various natural processes. For example, it gets incorporated into new rock formations, trapped in sedimentary layers, and even blown out to sea by sea spray. All these mechanisms prevent the never-ending buildup that the creationist argument relies on. So in short, they're only accounting for half the equation, probably because the other half completely destroys their claims.
So that means salt.
Okay, so right off the bat, I would say even if we granted him generous rates of salt removal, the net effect still favors salt accumulation, not removal. Therefore, the evidence still points to a young world or a young earth. Before you guys talk, let me mute this. Okay. Ben, what are your thoughts, brother?
Well, he is right about that. There are several mechanisms, and if he had read the creationist literature, he would know what they are, because this is a study from all the way back in 1990. Can I share my screen again? I did.
Yeah.
I do have a few slides on this. Are you seeing it?
Yeah.
Yeah.
Okay.
Can you
I
make
like
it
seeing your
larger?
guys' faces, so.
Sorry
So
about
this
that.
is
Can you make it bigger? Can you
all
go
right.
like-
Well, I'll just go ahead and do this. How's
yeah,
that?
that's perfect.
Okay. So this is a diagram I stole from Humphreys and others' original article from 1990. Okay, this shows all the different things that are happening. Okay, and so you see, I was a little simplistic in my. You asked me, Donny, to explain in 2 minutes in an elevator, right? And so I was a little simplistic. That's true. He's right about that. So there's not only rivers, you can see the rivers flowing into the ocean. There's also groundwater seepage flowing into the ocean as well from the continents. There's also hydrothermal vents that are spitting water up out into the ocean, and then there's exchange between the ocean and its seafloor. Okay, so there's all different kinds of things happening. There's stuff coming in from the atmosphere, the atmospheric and volcanic dust, and all sorts of stuff is happening. One thing that I wasn't aware of before I went back and studied this is that they now think almost there's a massive number I can't remember what the term 40% means, but there's a lot of salt coming into the oceans from what's called submarine something or other, but it means groundwater coming up into rivers and even into the ocean that is highly concentrated with salt because it's spent a lot of time underground, and it has a lot more salt dissolved in it because it's been in the groundwater system and not in rivers. And that accounts for a lot of the salt that's going into the ocean, actually. So here from the paper, on the left, you have the inputs of sodium into the oceans. And on the right, you have the outputs. Okay, so these are all the things that he talked about as all the stuff where salt is coming out of the oceans. This was accounted for in the original model. And if you see at the bottom of the left, see the numbers there? And the bottom, the total numbers on the right, the bottom numbers on the left look a little bit larger than the bottom numbers on the right. Is that what you guys are seeing? That's what I see. So that means the net effect is there's a whole lot more salt going in than coming out. And this is the final equation they use to determine the maximum time the maximum age that the oceans could be based on the ratio of salt going in to the ratio of salt going out, and then the amount of salt that's in there today. And they came up with the oceans have to be less than 62 million years old based on this equation. And there's the reference for you. Okay. That's all I had on that.
Sam, you might have some points. I know I have some more points, but let's allow Creaky Blinder to make a couple more points before because I know he's gonna focus on this. Go ahead, Sam.
Real quick, he said that a lot of the salt gets blown from salt spray back into the ocean. I'm not sure.
Yeah, I think that was an output.
How would that help? It just blows it into the ocean. It's not taken away.
I think the salt spraying is an output of salt. So that's a way that salt leaves the ocean. And actually, an article I read mentioned that if you live near the ocean, you experience this on your car. Water gets sprayed out of the ocean and it hits your car. The water evaporates and the salt crystallizes on your car and messes up your paint job. And so people who live near the ocean have to deal with this. So this is actually an output.
I do.
What?
I actually do live by the ocean. I took this picture, and you do get like a salt residuals, but that gets washed right back into the ocean.
Well, I don't know. They have it in their paper as an output. I guess they do have it as an input too. They have rivers sea spray, and the numbers about it. So salt is continuing.
Is the audio coming in, gentlemen? Let me know.
Continuing to accumulate in the oceans.
Salt is also always being removed. The balance is what keeps the oceans from becoming saturated over geological timescales. And the idea that salt is just endlessly accumulating is a creationist myth, and a pretty lazy one at that, since it ignores half the real-world processes.
And there's a rate at which that occurs, and we've measured it. And if the oceans are billions of years old, the ocean should be way past the saturation point. There should be as much salt in the oceans as there can be, and there's not. And so that is evidence, very good evidence, that the oceans are young.
He's a useless shite, that boy.
Well, when you ignore the fact that salt is also being removed, then that's what you're going to think, isn't it? Especially when you're so blinded by religion that it affects your ability to think rationally. Now, the creationist argument is that salt flows into the ocean from rivers and land masses, blah.
So are we so blinded by our religion from Christianity that we can't think straight, Ben? And what are your thoughts on his previous points too?
I already answered those.
Yeah,
He needs
he's
to
just
go do his
he's
homework.
basically just repeating, right?
He needs to go do his homework and read the literature on this, because what matters is what is the net flow of salt into the oceans. He's correct that there are mechanisms by which salt comes out of the oceans too. Okay, there we go. But what matters is the net rate at which salt goes into the oceans. And I showed you the data. It shows, and that comes from a paper. It has all the references in it. I showed you the reference. It's freely available online. You can go look it up and read it and check out the references. This is a legitimate argument. It's been a problem for deep time for well over a century now. It was recognized in the 1800s. And it has never gone away. Because the net amount of salt going in is higher than the net amount going out. I don't know what else to say on that. It's like,
well, you said it, and he needs to do his homework. I put together a couple slides here, which essentially just reiterates what you were saying, but maybe it'll kind of add to it, make it that much more powerful. But critics' response. So Creaky Blinder, hand waving appeals to unmeasured removal mechanisms. Conclusion, the salt in the sea evidence is a quantifiable, data-driven argument supporting a young Earth, and evolutionary rebuttals rely on faith in unobserved equilibria. And I like that point because he's saying that we as Christians are the ones blinded, so we can't think straight, but they're the ones that are actually relying or putting their faith in unobserved rescue mechanisms in terms of actually quantifying the amount. Because, and I put right here, even if we were to accept every one of Creaky Blinder's proposed removal mechanisms and then double them, it still doesn't offset the measured input rate. That means, according to the data, the oceans would have reached today's salinity in a small fraction of the supposed billions of years. The math just doesn't work for deep time. So I guess we could say, or challenge Creaky Blinder to show us the math. Show us the math. Do your homework. And an analogy. It's like being in a sinking boat with a hole in it the size of a basketball and trying to bail it out with a teaspoon. You're just trying to take out a little bit of water with a teaspoon, even though water is just gushing out and your boat is sinking rapidly. Sure, you're removing water, but nowhere near enough to stop the flood. So I think overall, Creaky Blinder actually failed to address this point, supporting a young Earth. And it's interesting because, Ben, you had that listed as an honorable mention. And so this is a powerful and in many ways irrefutable point of evidence for a young world. And yet it didn't even make it into your top 5, which means we have even more powerful arguments for a young Earth. Yeah, go ahead.
It used to be in my top 5. It used to be number 5, but you convinced me C14 should bump it out of there. So I put C14 in number 5 for you.
I did something right then. Appreciate that. Yeah, I love this.
I also want to say I'm really disappointed that Creaky Blinder showed a clip from the movie Snatch instead of from Peaky Blinders.
Right. Yeah.
What's up with that? Do better, man.
Cillian Murphy would be isn't that his name? Who plays
Cillian or
Thomas Shelby? Cillian. Yeah, I've heard it pronounced both ways. I don't know. He'd be disappointed. Sam, what are your thoughts, brother?
Yeah, it would have been nice. These are him addressing what was asked to be, a 1 or 2 minute elevator pitch. And so you gave him enough to where he should have been, if he's going to address it, if he's going to do a response video, put in a little bit of time and do the homework.
I'm pretty sure he just did what Donny said and assumed that because we're young Earth creationists presenting evidence for a young Earth, we must be wrong. And then imagined why we were wrong,
Right. Yeah, no, it's exactly what he did. Okay, gentlemen, to avoid the echo now, I'm going to turn the screen itself. I'm going to take that off of mute. We're going to unmute that, which means there could be an echo if we talk. But let's play a little bit more from Creaky Blinder. Is it true that we young earth creationists have no clue how science works? I guess we're leaving that up to the audience so far.
Blah, blah, blah. And if you divide the total amount of salt in the ocean by the early input, you get a number that's far less than billions. Okay, and that doesn't prove anything, apart from you don't understand or you're deliberately misrepresenting the process that puts salt and removes it from the oceans. So nice try, but you're so wrong, it's like you're the mayor of Rome.
When I talk, do you get an echo, or is it just when someone else talks? Like, can you hear an echo from me?
Look,
Okay.
I can hear it when
Yeah.
Not
I guess
you.
it's probably because I'm the one screen sharing. But anyways, he says that loudly and confidently, but we clearly showed that all he has are rescue devices. He still has to do his homework. And when we even give him everything that he wants, everything that he needs, it's still a problem. It's still something that needs to be resolved. Sam, you're going to say something, brother? I'll go mute this.
Yeah. I just wanted to compliment him on his rhetoric game. That is on point. Right? I'm going to give him that. I think he's got good rhetoric.
Yeah, we'll give him the rhetoric. We'll give him a point for rhetoric. 99% rhetoric, maybe 1% substance. And we like a little rhetoric around here. So, okay, gentlemen, let's continue to the next point.
Bronzeville.
Another one, if I had time, would be the cold spots they found in the mantle, the Earth's mantle near the core. These are measurements that are made where they.
So Ben, this is going to be a big one. This is going to be a major one. You had an entire segment on CPT and how a confirmed prediction or expectation of it are these cold, dense slabs found deep within Earth's mantle. And so let's allow him to make his argument. So we'll let him speak for a minute or two, and then we'll throw it over to you to get your overall thoughts on what he's saying. Is he misrepresenting it? Do his rescue devices work? So on and so forth.
For a temperature based on the motion of the material down there, and they found these cold spots that are something like, I think, 500 to 1,000 degrees Celsius colder than the surrounding mantle.
The claim goes something like this. These cold spots exist, and if the Earth were billions of years old, everything would have completely equilibrated by now. Therefore, the Earth is young. It's a textbook straw man. The cold spots exist, that part is true, but the reason they exist completely disproves the creationist argument. Imagine a huge cold slab of rock from the Earth's surface being shoved down over millions of years into the superheated molten rock of the mantle. That's exactly what's happening. The sinking plate is still a different temperature from the surrounding mantle, and it takes a very, very long time for it to heat up, which is what we are detecting. The cold spots are not evidence of a young Earth. They are direct evidence of plate tectonics in action. And you cannot have subduction, a process that happens at a snail's pace over millions of years, in a young Earth.
Okay, and so over time, the heat would equilibrate into those areas. And what the cold areas show is that...
Why don't we stop it there? He said a lot there. And I'm curious as to, Ben, your overall thoughts on his argument here.
I haven't personally done the math about how long it would take for the temperature to equilibrate with the mantle. I am trusting my sources on that. So that would be an area where, again, though, you have to do the math to show that it's wrong. And I know where I could find that and show it to you. I just didn't do it today. But what he did say is he's assuming that the rate of subduction is the same as it has been observed today, and that's not the model. We're saying that it probably occurred faster in the past, and we presented evidence for that. And part of the evidence is that there are cold slabs down there. He's assuming that the evidence is explained by the fact that subduction occurred slowly. But that's precisely what the evidence does not confirm, because
aren't you showing that no, it couldn't have occurred slowly? Because if it actually did, if that's what we're gonna, because he's saying, oh, this is evidence for plate tectonics over millions of years. But if that really were the case, then these cold slabs that we find in multiple locations in the Earth should have actually warmed up or even melted. But the fact that they're cool actually supports what we're saying and what you presented on, Ben, that no, this is plate tectonics, but it's rapid plate tectonics, not the snail pace movements of the plates through the floodwaters, but the continental sprint, as I've heard some people describe it, meters per second movements.
Yeah. And Baumgartner presented a mechanism for how that could happen that's supported in the secular literature by experiments. Again, this weird thing that I think is part of science or something. And Baumgartner noticed that, and he's like, well, this could explain a rapid plate tectonic system. I'm losing my voice here.
It's understandable, brother. You've been presenting quite a bit today. You got good endurance.
I'm a bachelor, so I drink right out of the...
Take a well-deserved sip of that, brother.
But I explained the mechanism of rapid plate tectonics as having to do with thermal runaway, which I've had trouble getting people to understand before. I was on a podcast once. I believe this was called the Still Unbelievable podcast. They critiqued that Unbelievable show with Justin Brierley back in the day. And so they had me on, and I tried to explain this thermal runaway to them. And when they actually published the podcast, they published clips of him commenting later on what I said. And he claimed I must have used the wrong term because he Googled thermal runaway. And it was like, well, this isn't what he was saying. I don't know what he's talking about. And then he posted all of the papers and references that I gave him in advance of my appearance on the podcast. And I'm like, you didn't read the references that I gave you, because if you had, you would have seen on the very first page of the CPT paper the term thermal runaway and the explanation of what it is. They just don't read our papers. They don't read our stuff. They just assume we're stupid. And this guy, in his case, he assumed that I just was using the wrong term or something, even on the Young Earth view. And I'm like, you don't even understand what thermal runaway means. I tried to explain it to you. It means a positive feedback system where, unlike the normal situation, like a hot air balloon, where hotter air gets less dense and therefore it rises in a gravitational field, and cold air descends in a gravitational field because it's more dense. So gravity pulls it down more. Very bad language there, but whatever. Unlike that situation, there's a special kind of rock that when it's under this heavy shearing force, heat and pressure, its crystal structure deforms to such an extent that it breaks the normal relation between heat and density. And it becomes more dense as it gets hotter. And because it gets more dense as it gets hotter, it goes down in the mantle faster, it subducts faster, pulled down by the energy of gravity. It's all happening because of gravity and density, okay? And because it gets denser, it gets pulled down faster, which creates more friction, which creates more heat, which deforms it more, causing it to get even denser. That's called a positive feedback mechanism. And that's what is meant by runaway. It means if you see it on a graph, it runs away. It goes whoop, way up. Sort of like the U.S. federal government national debt is doing right now. It's a positive feedback mechanism because as we borrow more money, we have to borrow even more to pay our debts and pay our interest on our debt. And that increases our debt, which increases our interest payments. And that means every year we have to borrow even more. It's a positive feedback loop where one thing feeds into the other, and eventually it's going to get way out of control. That's what we mean by thermal runaway. It's what we think happened to the mantle rock or the oceanic crust rock during the flood. It got denser, more and more dense, which caused it to go faster, more heat, caused more deformation, denser. And the prediction then of that particular mechanism is it would go all the way down to the core because that's as far as it can go. That's where gravity ends, right? And so it just goes faster and faster and faster, and then goes all shoot, whatever, all the way down. That's the mechanism that Baumgartner proposed, and there's physical evidence for it. Is there anything else he said there that I can't remember?
He does continue, I think, for 30 or so more seconds, but that was thorough. I mean, what you just said was thorough, and it shows that there's physical evidence that we can see and look at based on Dr. Baumgartner's model. And so, okay.
It's not just his. The mechanism of thermal runaway is from the secular literature too. It's not his own. He didn't do those experiments. He referred to them in his original paper.
Right.
You've got a whole playlist. We good? You've got playlists of Professor David McQueen, who's a very established geologist, who's unfortunately no longer with us. And George Bond, he was an engineer in Australia with an emphasis on geology because he did highway and roadway work. They spoke about this argument extensively, numerous times, both of them, and they did all of the math for anyone who wants to dive in deeper to this argument. I believe, Donny, on your channel, you've got a playlist to Professor McQueen, and you can just go through there and you can find all of this stuff. I mean, I wouldn't be surprised if there's even a show with that title on there.
And both of those brothers are with the Lord.
That's right.
And we look forward to seeing them again. As Christians, we have that hope. And so, okay, I appreciate that, Sam. Let's continue here. I think there's just a little bit more on the cold slabs, but we'll see, because he's coming. He's going to be coming at you, Sam, real soon. Transcendental argument. He's not a big fan. We're going to see what you think of what he says. Anyways, before that, though, here we go. Actually, I might have to unmute it. Oh, so frustrating that what changed here with the screen share. Okay, here we go.
There's not been enough time for that heat to equilibrate there.
Exactly, and that's how we can be so certain that the Earth is a little bit older than 6,000 years. I love it when they debunk themselves. It makes my life so much easier.
So those are two really good points.
Yeah.
I don't see how that's us debunking ourselves. No, we're actually showing that if rapid plate subduction due to catastrophic plate tectonics or flood processes were not the best explanation for these cold slabs, and what he's saying, or the secular geologic model could best explain those cold slabs, then again, they should be a higher temperature. They should be at least a lot warmer or melted. So I'm not, it almost seems like he's the one that has no clue what we're saying, Ben. And actually, I'm going to have him finish his thoughts here. And then, Ben, I want to get your concluding thoughts on what he's saying before we move into the third piece that we touched on.
Yeah, they are. I completely agree. But they were good at showing why you're wrong, not why you're right.
AI.
Okay, perfect time, because there's a commercial break. So let me mute this again. Ben, what are your concluding thoughts on his response there?
It's hard to think about that because it doesn't seem to have required a lot of thought to say it. I feel like his mouth outran his brain a little bit there. I really don't know what his point was in some of that stuff. He didn't seem to be following some of the reasoning very well.
Yeah.
I don't know, man. I got nothing.
Well, it's like you said earlier, they're not really reading our literature. They're not doing, at least some of these more popular YouTubers like Creaky Blinder, they're not doing the homework that they need to do. They're not doing their due diligence to even understand our models, understand what we're saying, to adequately respond. Okay, let's move on to the next point now. Share screen, unmute. Sam, I think he's coming at you now, brother. Let's see.
Let me sit down. So if we're going to talk about science, I would point out, like I have with Andrew, that science has preconditions, and the naturalist, the atheist, their worldview cannot satisfy those preconditions.
Science relies on the observation of the natural world, and the existence of observable phenomena and events that can be studied is a basic precondition, I suppose. I don't get what's confusing about this, though, or how you're going to try and use it against us. Are you claiming that the universe doesn't follow predictable laws?
And then I would make a positive argument that it is the Christian worldview alone that satisfies those preconditions for science intelligibility, and therefore Christianity is objectively proven. And the critic, like Andrew, is living in God's world but pretending that there is no God. And I've made these arguments with him, with Erica, with many others. They can't address it.
Well, the reason critics or atheists can't address it is because the argument itself is a rigged game. It's like arguing with somebody who says they've got an invisible, immaterial dragon who lives in a garage. When you ask for proof, they say, well, the dragon's invisible and immaterial, so of course you can't see it. When you try to show them then that there's nothing there, they say, see, the dragon is a master of hiding. The argument assumes its own truth as a premise and then dismisses any counter-argument by saying that the counter-argument is only possible because the premise is true. It's nonsense.
There have been atheist philosophers that have made these arguments.
Sam, why don't we stop it there for now, brother? What are your initial thoughts on what he's saying? And then once you give those, we'll let him continue his argument. Now, he does have the kind of rhetoric, energy, and approach of evolutionists that we love to debate. And so perhaps Creaky Blinder would step into the debate coliseum at some point in the future. But Sam, what are your thoughts on what he's saying, brother?
I mean, he got me. What am I going to do with that? You know,
No choice but to convert, right, Sam?
so yeah, I mean, we could dive into it a little bit. You can move forward. So as both of you know, when we cite Christians, like if I was to cite Christian philosophers that have made this argument, he would hand wave it away. No different than if you reference a biblical journal. They'd say, well, you know, that's not a real peer-reviewed journal. So I referenced Anthony Flew. Remember, this was an argument here that was just an elevator argument. But the reason why I referenced Anthony Flew, and he'll later on go on to say that it was just some atheist. Well, so first of all, Anthony Flew wasn't. He was a very prominent, arguably one of the most influential atheist philosophers of our very recent history. And his arguments were very powerful. And so I referenced him so he could maybe look into it. But the argument, it's going to go like this. If we'll make it really simple at first. If I were to ask him, what is it within his metaphysical scheme that dictates possibility and impossibility? What is it that provides for the uniformity of nature? And you heard him say it. He said, well, are you saying that that reality or nature doesn't follow certain laws? The argument here is about those laws. And so as a Christian, when we invoke those laws, we're invoking something that has it has a nature, an ontology. It stands in laws that stand in a cause and effect relationship, laws that the God who is uses to uphold all things by the power of his word. He uses laws of nature to do that. The critics don't like that. Okay, fine. So explain to me what these laws are on their terms. And they're going to say, well, it's just semantics, abstract representations of the way things are. Well, if that's the case, then you have nothing dictating possibility and impossibility. You have nothing that stands in a cause and effect relationship, providing for the uniformity of nature. Why is that a problem? Because evolution is predicated on uniformity throughout this time index. Millions and millions of years of these processes. The present conditions are the key to the past, so they'll say. And it's going to extrapolate well beyond that when we're talking about, on their model, the Big Bang, that everything came from a singularity, and all of that is based on this uniformity of things acting, the physical world acting according to these laws. Hopefully you guys are following the argument. It's pretty simple. So then we can reference some other people. So Anthony Flew, I like to reference him because when we talk about science with the unbeliever, as many of you know, when they get refuted, which usually doesn't take long, what do? As a Christian, they want to start attacking God, prove you're God and such. And so one of the attacks the unbelievers will make against the biblical worldview is that there are events in the Bible that don't comport with reality. We call them miracles. Well, atheist philosophers have been arguing that the Bible is false, no different than the internet atheists, because of these miracles. Anthony Flew come to realize that the only way he could defend an argument like that is if he could justify invoking these laws. If he wants to say that a miracle is impossible, what is he referring to? He can't refer to laws of nature if they are just abstract. Okay, so there's been much written. So I have a book here. I don't know if you guys have ever heard of Norman Geisler. This is Norman Geisler's big book of apologetics. And miracles might be one of the largest sections in this book. And you'll see how they try to, define a miracle in a way that they don't have to deal with it, or try to say that it doesn't comport with reality. But all of these arguments are problematic because they are all presupposing. A presupposition would be like a belief that is not tested by the natural science. Presuppositions would be something like you have a rational mind, or that there are two or more minds in the world, or that there is uniformity of nature, causal connection, all of this stuff. You can call it mumbo jumbo. You can call it what you want. But the problem is, if you are an unbeliever and you want to say that there is no God because you have science, then on those terms, you have to account for the preconditions of science, some of which would be the laws. And so I have another quote here that I like to invoke. I'll do two really quick. So this one's from Robert Jastrow. He's a NASA physicist. And he says here, and this is the end of a much larger quote, you can look into it, but he quotes here that there are what I or anyone would call supernatural forces at work. Now, I think a scientifically proven fact. So he understands that his field of study doesn't make sense unless these laws are real. The other person and he's not just some guy, and even if he was just some guy, that doesn't mean you can hand wave the argument away. Stephen Hawking, he's not just some guy. Stephen Hawking says something along the lines of, as long as there is a law like gravity, then the universe can and will create itself out of nothing. A lot of problems with that statement. But notice he's not invoking this law that he's calling gravity as something that's purely abstract. But if I were to ask Stephen Hawking, what is it that imposes those laws, he's going to have a problem. He's not going to be able to account for these laws that he's trying to invoke in order to argue that there is no God. It's a powerful argument. There are many people that have wrestled with this argument. It's not necessarily the transcendental argument. I think he's trying to respond to a transcendental argument. I can give the transcendental argument, but instead I'm referencing people that were atheists and agnostics to say that I'm not the only one that's thought of this. So Donny, I don't know if you're...
Yeah, that was great. Well, you know what? Creaky Blinder isn't going to be debating you after that.
He can. I've moved over to TikTok. It's a horrible place to be, but you can find me there. Redefine Living. I've got my same little thing here, and I will take the time for somebody who wants to have a real conversation. If you want to just say, poo-poo on God, I'm not really interested in that. But if I've missed something, then yeah, bring it to my attention. I'd love to talk about it.
I need to join you.
You do. You do.
On there. Okay, I'm unmuting the screen share, which means possible echo if you guys talk. Let's see what else Mr. Peaky Blinder wannabe has to say. Here we go.
That's the argument I mention regularly that brought Anthony Flew to deism, one of them anyway. So they're powerful arguments. But that would be the argument that I would make.
Whoa, so one person went from being an atheist to being religious. Whoa, cool, amazing. The existence of a single person who changed his mind doesn't mean your argument is logically sound or a slam dunk. It's an appeal to authority, and a very narrow one at that. Because for every Anthony Flew who found the arguments compelling, you can find another dozen philosophers and scientists who have meticulously dismantled them.
Architecture and interior design?
Ad after ad on YouTube, eh? Okay, that is another sign to hand it back to Sam or Ben, of course, if you had anything you wanted to say in response. It's just one guy, Sam. It's just one guy. You think this is a slam dunk? For every one guy you show me that's converted to either, deism, theism, or even Christianity, I could show you 10 that are not persuaded. What say you, Sam?
Yeah, I mean, that's a non sequitur, but how
many Christians are there in the world and how many atheists? I forgot.
I mean,
atheism is a dying religion, isn't it?
Charles Darwin was just one guy.
I mean,
so
he's making an argument from popularity right there, right?
No, he's cooked right there. I mean, that's an excellent point. So there are many people, all throughout the history of the world that realize that the heavens do declare the glory of God, and that all creation declares the glory of God. So, atheists, they're still a minority. But those of us that understand the things to come realize that minority will continue to increase as people get more rebellious and things come to an end. But even if all of that stuff, even if it was just one guy, like it's not a rebuttal. And he wasn't just some guy. He was somebody, but even still.
You're referring to an argument that he made, right?
Yeah, that's well reasoned, and he was
and
a
well
philosopher.
known, so he could go read it if he wanted to.
But yet the argument that he made that you're referring to was not actually addressed by Creaky Blinder.
Yeah, that's correct. And that's why I specifically like using somebody like Anthony Flew, because he wrote a lot about miracles. You realize that he really has no way to object to them. And then when we apply that to the physical world, it's very obvious that the physical world is in submission to laws of nature that are not physical. That, I don't know how the atheists sleep at night knowing that. That is a huge problem for them. That's a huge problem for them.
Yeah, there's many huge problems for the atheists. We've done program after program showing exactly why you'd really have to deny reality. I mean, anyways, here we go. Screen shared again. Gentlemen, let's see what else Creaky Blinder has for us.
There's also hot blobs, so it's not just cold slabs. It's hot blobs, and that just compounds the problem. Because I didn't have hot coffee, I had cold water with ice cubes in it, and they're melted now.
Yeah.
How do you explain that?
How do you explain how ice melts?
Another quick point to make on that.
So obviously, and gentlemen, we'll get your thoughts. He missed the analogy in relation to the cold slabs, okay, found deep within the earth, deep within Earth's mantle. If I were to have a coffee next to me, steam's coming out of it, it's hot, and I were to put a couple ice cubes in it. Well, if I were to leave the room and my wife came down, shortly after, and the ice cubes had not yet melted, well, she could conclude that I've only stepped away for a minute or so. The coffee's still hot. The ice cubes are still there. Okay. But if the coffee was cold and the ice cubes were completely melted, then one could rightly conclude that, the coffee's been sitting there for a while. So the fact that we find these cold slabs deep within the earth that haven't warmed up to the surrounding material or haven't melted completely tells us that they were taken down there just a few thousand years ago rather than millions of years ago. That's how I use the analogy. That's how I understood your use of the analogy, Sam. And he had a cute little rhetorical response, but he didn't actually address the significance of the analogy. What are your thoughts? We'll start with you, Sam.
Yeah, I think it's bifold. If you had a bucket of warm water and you dumped some really hot rocks and ice cubes in that bucket, then you could really show. I mean, in the same way, I think your analogy works. Just a cup of hot coffee with ice cube. But if you had a bucket of warm water or lukewarm water, and you put something hot in there and something cold in there, then chances are it hasn't been sitting there for very long. So you could point to either one, the cold slabs or the hot blobs.
Cold slabs versus hot blobs, epic debate coming to you this summer. Ben, anything you want to add, brother?
That's because of the second law of thermodynamics. It's because of entropy. The heat will tend to disperse throughout the volume equally. That's what entropy does.
Don't say the word entropy, Ben, because it triggers the skeptics. It gets them thinking about genetic entropy, and it gets them thinking about Dr. John Sanford. And what has Dr. John Sanford published? Oh, just about 100 peer-reviewed articles. I just experienced that in a formal debate recently. Genetic
by the way,
Ben?
I wanted to mention I did watch your debate with PhD Tony and that other guy Jeremy or something.
Yeah, Eric.
That was a crushing, man. I don't think I've seen a debate that one-sided in a long time.
Yeah, well, I appreciate that. Hey, that means a lot coming from you, brother, because you're crushing critic after critic in this series we've been doing.
It's like when a guy starts out what's supposed to be his opening statement complaining that he wasn't aware of the debate topic, and then he claims that genetics is not part of biology, so it's not part of the topic that he was told it would be.
Right, because then I asked him, you were aware that the topic resolution was biological evolution on trial? Well, yeah, but I didn't think that we're only going to focus on genetics. It's like, well, I'm pointing out in my opening statement that your appeal to fossils is low quality, low confidence, but you can counter my framing of the debate if you'd like. I mean,
and then he was
like he knew that that's true. Genetics is a better way to answer the question of ancestry, right?
And he was the first one to go outside of biology. He went outside of biology and said, well, I can prove that young Earth is wrong with one piece of falsifying evidence, and therefore I don't have to take any of this other evidence seriously. Right. Like, that right there is the problem with the falsification criterion.
Yeah. Yeah, it's true. Lorraine, did he publish on genetic entropy? Yes. In the Q&A section, they were attacking Dr. John Sanford. Did he publish in the peer-reviewed literature? I said yes. Did he publish on genetic entropy? I said yes. They challenged me to name one, and I wanted to see if they, like you said, Ben, have they done their homework? Name us, because if they prepared adequately for the debate, they should know at least a single paper that Dr. John Sanford has published. But anyways, Dr. Rob Carter and Dr. John Sanford, which is the paper I typically cite, they published in the peer-reviewed literature on the genetic degeneration of the H1N1 virus. That's in the peer-reviewed literature, completely consistent with genetic entropy expectations. Ben, I think you're familiar with that one.
Oh, yeah. That one's really interesting, too, because I don't know if this is in the actual paper, but they found a strain of the virus, which is actually the influenza virus from the 1918 epidemic that has survived for a long time. It's been degrading since then. But they found a strain that broke the trend, right? It was way off from the rest of the H1N1 virus. And so the H1N1 virus was sort of going down like this. They found another strain that was way up here. And they figured out that this was a strain that had been frozen in a Russian lab for several decades and somehow got out and infected people again. And so it was literally a strain from a few decades earlier that got out into the wild from a lab leak.
Wow.
And it showed the same degeneration, even though it was offset a couple decades from the regular wild type strain. Really interesting stuff.
That's incredible.
Yeah.
And there's the paper for those that want to, and these guys in the Q&A, they wanted me to cite a paper. Obviously, there's many we can cite. This is a major one. But why are we always going to do the homework for the evolutionists, right? If we keep doing the homework for them, then they're never going to go do it themselves.
It's like teach a man to fish.
Yeah. Right. Yeah, exactly. So, okay. Very good stuff. Appreciate the feedback. All right. Let me make sure that there's not going to be any echo here. Okay. I think we're good. Okay.
Blah, 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 blah.
Yeah. Now there will be echo, actually. Here we go.
That is that we touched on it sort of, but to be clear, if the rate of plate subduction that we observe now resulted in those cold spots being down there, the rate that we observe now is...
Hey, that guy talking, I know him. Ben, you know him? Ben, he's a good guy. Demolishes old Earth.
So slow that...
Confirms with 100% certainty that the Earth cannot possibly only be 6,000 years old?
Even way before those slabs would have gotten to that distance down in the mantle, they would have melted already and essentially become part of the mantle.
Oh dear, I think that Ben guy is meant to be their guest expert, mind. Now, the subducting plate isn't just a block of ice you've dropped into a hot tub, is it, Ben? It's a massive, cold, dense slab of rock, much like yourself. And while it's true that the mantle is incredibly hot, it's also a solid that behaves more like an extremely thick, viscous liquid. And the speed of heat transfer through this material is astonishingly slow. So even though the slab is surrounded by heat, it takes millions of years for that heat to fully penetrate and warm the slab up. The presence of these cold spots is actually one of the most compelling pieces of evidence for an old Earth, because a young Earth wouldn't have had enough time pass for these massive slabs to sink to that depth in the first place.
The rate of subduction is an issue there as well, because I think you did mention that, Donnie.
We'll let the video keep playing, but it seems like circular reasoning or assuming that the uniformitarian or actualist model is true to say that this is a refutation of the young Earth model because we don't have enough time for those cold slabs to subduct to where they are. But yet we're pointing out that no, this was a prediction based on rapid plate subduction, based on catastrophic plate tectonics, and the fact that where we find them and how they find them and the temperatures we find them in is more consistent with a young Earth model. So anyways, I'm not very impressed with his line of reasoning here, but I am curious as to your thoughts, Ben, but let's kind of allow the video to play until this specific portion's done. Then we'll get your thoughts.
But just to be clear, it's like, as it's going down, if it's going down that slowly, it's equilibrating in temperature as it moves. So it's also evidence that it had to be really rapid subduction.
That's the core of the creationist argument, and it's a perfect example of where they have to abandon real-world physics to make their claims work. The rapid subduction claim isn't based on an observation, is it? It's a desperate ad hoc idea invented to try and explain away a massive piece of evidence for an old Earth. It's the equivalent of seeing a car moving at 30 miles per hour and then claiming the only way it could have arrived at its destination is if it went 300 miles per hour for a few minutes. It just doesn't make any sense, and it's not supported by any of the other thousands of data points we have from geology, seismology, or physics.
Well, there's an ad, so that's our cue. But I would say this, the analogy would be better understood that if we saw the result of a car crash or collision, and it was clearly a devastating event, a devastating crash, okay? And so clearly those cars had to have been coming at each other at, let's say, 100 kilometers an hour very quickly for the result that we'd be looking at, okay? But the evolutionists would say, no, those cars were just coming at each other at, 2 kilometers an hour. And then at that point, you'd expect either just a fender bender or just a little bit of damage, right? No injuries. But no, what we would actually see in, I think, the appropriate analogy is that, no, these cars had to come at each other at 100 kilometers an hour in the same way that plates have to be moving at meters per second movements rather than the snail pace movements that uniformitarians believe in to adequately explain the geologic features on the Earth. But anyways, Ben, what are your thoughts on those couple minutes there, brother?
That was a pretty good analogy. One of my thoughts was, as an evolutionist, shouldn't you understand how something that occurs at a slow rate accumulates to a lot of change over a long period of time, which is what we're dealing with on the model of equilibrating the temperatures in the Earth's mantle, okay? It doesn't have to be a super fast rate of equilibration of the temperature if the Earth is supposed to be billions of years old, okay? Or whenever those slabs got down there. And I never heard him give his theory of how the cold slabs got down there. And he doesn't seem to understand. He seems to think that they must be happening they must be subducting at a slow rate because they're cold or something. But you're right. That's just exactly the opposite is the case. So I don't know how to argue with that other than to say that's just, he's not understanding the situation. As I said in the presentation, I have read some attempts to explain this on an old Earth model that involve a massive collision with, an extra planetary body of some sort that hits the Earth, because that's the only thing they can get to, like, how does it get that far down into the mantle? It has to hit the Earth with a huge amount of force to get that far down. Whereas the CPT model explains where that force comes from. It just comes from the Earth's gravity and the thermal runaway process that I described. But they have to explain how this cold stuff got way down in the mantle near the core. And the way I've seen it tried to explain is there's just this big moon or something. Maybe it was the moon, our moon, I don't remember. Or the collision that created our moon. Like they say that, well, our moon comes from a collision with another planet or something, and half of it amalgamated into the Earth, and the other half became the moon or something like that. And it's like,
wild
yeah,
story.
but all that had to occur at least 4 billion years ago, because no life is going to survive that. The oceans aren't going to survive that. That's a worse cataclysm than the flood. Nothing's going to survive that kind of a cataclysm. So, and they say life began around 3.8 billion years ago. So you're still dealing with a massive time scale after that occurs. And that just doesn't fit the data. It doesn't fit the idea of a cold stuff down there. And again, the other thing is, I was asking him if he thinks that the physics doesn't bear it out. Well, show it. Show your work. I would need to see that to be persuaded. Show me how fast temperature equilibrates in the mantle, or how slow in his case, and show that it doesn't go fast enough to explain. And by the way, I didn't hear how old he thinks those cold slabs are. How old does he think they are? He didn't take any positions at all that would help me check his work. So I don't know. He's just making a bunch of assertions. I don't know.
They are experts at making assertions, which is why when I debate, I love calling them out on their that's an assertion, back it up, right? And one could say he wouldn't make a very good detective. And as you said, Ben, I don't think he understands the situation. So well said, brother. Sam, anything you want to add before we continue?
Yeah, he accused you of making it up to explain the data, but that was a prediction, right?
The cold slabs, I'm not 100% sure if it was actually predicted before the cold slabs were discovered. So I would have to look that up and ask. I was actually trying to figure that out this afternoon. I couldn't find it, but I do know they knew it by 1994, which was when the major multi-author study on CPT was published, because the graphic that I showed you is from that paper. But Baumgartner had the idea and published on it in the early 1980s, so about 10 years before that. So I don't actually know if they predicted the cold slabs or if those were already known to be there. But it is generally acceptable in science to say that a theory predicts this, even if the theory came after the data. Scientists say that all the time, and that's how I meant it when I said that.
I do have a clip that I uploaded because I had Dr. John Baumgartner on for a nearly 4-hour seminar on CPT. It was really good. We had a whole section in it where we discussed the cold slabs and whether or not it was a prediction or an expectation or how it basically fits in the model. And so I clipped that out as its own separate upload, which I can, attach in the comment section or something after, and people can.
Yeah, because he would know. What did he say, by the way? Do you remember?
Well, he said that it wasn't necessarily like a novel prediction. If I remember correctly, they did know about it.
Okay.
But it fits so nicely and neatly with the catastrophic plate tectonics model. So I think we got to figure out what's the best way to iterate that argument. Like if it's not a future testable prediction, like what is it? Because I know there are a lot of creationists that would go around saying that it was. So
well, it would be part of the theoretical virtue, which are the values that by which you judge scientific theories. One of them is explanatory power. Yeah. And that would fit under that because it explains the data that we have.
Right.
Yeah. Okay.
Yeah, that's something that they can't argue with. I mean, if they don't have a mechanism to get those down there, and explain why they're still down there on their timeline, then they have a problem. So if it fits really nicely with ours, then that's just calling it whatever they want to call it. That's not a rebuttal.
Yeah, in science, you are supposed to be doing what's called inferences to the best explanation. And what that means is you compare competing models according to these criteria called the theoretical virtues, and you just try to decide which one is better by those criteria. And when it comes to the cold slabs, I mean, the theories I've seen on the secular model are just crazy or don't work.
Right.
And it's possible I've not seen some theories. I haven't studied this extensively. But, and this is why I put CPT at the top of my list, because there's several examples there where the young Earth model is demonstrably better than anything that the old Earth people have come up with, especially the heat dynamo theory is not workable. And Humphreys actually did make time predictions, right? In that case, I emphasize that. Like, Humphreys made these predictions about planetary magnetic fields before the data was observed.
Yeah.
And the same thing with the lava flows was
the
also
rapid magnetic reversals at the flood, right?
Yeah. And so those were real, I guess, predictions, right?
Yeah. And Dr. Lyle's predictions about
James
what
Webb
the
Space Telescope.
James Webb would find.
Yeah.
And how the critics would respond, predicted that as well.
Yes. That's
Isn't that amazing when you can predict how the critics would respond, what their rescue devices are? And I wanted to say this, Ben. So as you were presenting, it was such a good, thorough dismantling of an old Earth and evolution at the same time, because common descent requires an old Earth. You take time away from them, well, they're not going to get fish to fishermen and bacteria to biologist evolution. We've had several critics in the chat, and nobody was able to counter what you were saying. And one guy, before you even brought up the ASC model, who was Jam. Thank you very much, Jam. We do appreciate our critics here because we want to plant seeds and get you thinking. And so anyways, Jam had said, oh, but how do you address distant starlight? And then confirmed testable prediction. You must have known, Ben, that someone would mention that, because then your point number 3 was the ASC model, and you debunked distant starlight without even seeing that the critics were bringing it up in the chat. And so, yeah, anyways, I appreciate that about your presentation. So, okay, gentlemen, let's bring this up. And I think we're moving into the final point, the helium and zircon crystals. So we've moved along smoothly. He's said a lot, but we've made sure to address them point by point. So let's start playing it right now. This is another challenge I want to issue to theistic evolutionists like Redeem Zoomer. Let's see you respond.
I've responded, and I genuinely hope that you find the information I've shared to be helpful.
So here's the paper I'd highly recommend reading. We can see if Redeem Zoomer can refute it. Helium diffusion rates support accelerated nuclear decay. So we know the rates of helium diffusion, and these zircon crystals are supposedly billions of years old, and uranium to lead gives off helium. Helium is produced. It can move through rocks. Since rocks are porous, the gas escapes through the rocks, and helium being a slippery molecule, we shouldn't find the kind of helium that we have in these zircon crystals, because billions of years, you'd have plenty of time for the helium to basically leak out and escape into the atmosphere.
Now, the core issue with the argument about helium and zircon crystals is that it's based on yet another flawed assumption. The claim is that because helium is a tiny slippery atom, it should have diffused out of the crystals over millions of years.
Yeah, I can hear that.
Yeah, I wanted to go faster for just getting through what we've heard before, what we were saying, but let's go a little slower with what he's saying.
The claim is that because helium is a tiny slippery atom, it should have diffused out of the crystals over millions of years, and the fact that it hasn't means that the Earth is young. But here's the problem in a nutshell. The argument relies on a simplified model of helium diffusion that ignores key factors like the rock's temperature history and the effects of radiation damage on the crystal structure. And to make that argument work, creationists must invoke the idea of accelerated nuclear decay. That radioactive decay rates were much faster in the past. And this is just another ad hoc explanation that violates established physics. It's another glorious example of a self-refuting premise.
They'll immediately start.
Okay, let me make a couple points first, and then we'll get your thoughts, Ben. I put together some slides here. I've heard, okay, firstly, Dr. Russell Humphreys has very comprehensively addressed all of these objections, and I'm going to show people, I'm going to direct them to an article on creation.com where there's a table. It's a perfect table of the criticisms, who said it, and how you refute it. It's too good to be true. And I never see critics, because we also had Simon Dan respond to a video that I did with Michael J. Ord, where we talked about helium diffusion and how the abundance of helium that we find in these zircon crystals puts an age limit on these zircon crystals in the age of the earth, of course, because zircons are claimed to be 1 billion plus years old. And Simon Dan, who's another popular evolutionist YouTuber, he basically made the same points about differences in temperatures in zircons and in the earth itself throughout history. So anyways, here's a few points I want to make, and then I want to show people Dr. Russell Humphrey's responses to the critics, and then we'll get your thoughts, gentlemen. Changing past temperatures, we'll focus specifically on this one, doesn't rescue the deep time model, doesn't rescue Peaky Blinder here, or Creaky Blinder. It actually worsens the problem. Higher past heat would, so let's say in the past it was higher or lower. Let's address both. Higher past heat would accelerate helium loss, which means even less helium should remain. So it actually makes the problem worse for them. Yet we find massive retention. That means the rock hasn't been cooling slowly for 1 billion years. It's young. The helium data still point to thousands of years, not millions or billions. If critics say it was hotter in the past, that makes diffusion faster and their problem worse. So that doesn't help. If they say it was colder in the past, that contradicts the measured geothermal data and requires billions of years of radioactive decay without what? Without heat production. So there's a problem for their model. In both cases, they lose. So regardless of how you want to look at it, they lose. Dr. Russell Humphreys has pointed this out anyways. The helium is still there. The data still say the rocks are young. The rate team modeled all reasonable temperature histories. They did their work. They did their due diligence. This kind of reminds me of the C14 rescue devices, where they say, oh, contamination, maybe in the lab, or environmental contamination. Or they'll say, as I heard Dr. Hugh Ross argue in his Jason Lyle debate, well, decay processes from nearby rocks, basically. Nearby nuclear material could recharge C14 in diamonds. Rate team looked at that. It's been addressed. You would need 13 to 14 times the amount of nuclear material to basically recharge diamonds. It doesn't work. So anyways, the rate team looked at this, and every single one yields a young age for the zircons, not billions of years. I'd recommend people check out this article here, creation.com. Dr. Russell Humphreys, helium evidence for a young world continues to confound critics. But anyways, if you go down to this table, this is great. List of critics and my responses. Notice this one from Hugh Ross. So here's the date. Hugh Ross, here's the reference. Really utilize this, fellow creationists. Hugh Ross said helium is slippery. Even before I read Dr. Humphrey's response, I was like, yeah, that's the point. Anyways, he says, yes, slippery is what we want in order to date zircons by the rate with which helium slits out of them. That's the whole point, is it's such a slippery atom that we shouldn't find as much as we do find in these zircons. And so anyways, you can see more from Hugh Ross and Kevin Hankey, who we've responded to here, Randy Isaac. This one here from Gary Lokelt, if that's how you say it. I think he's the one from, yeah, it is, from Reasons to Believe. Dr. Humphreys and him had a back and forth many times. And you can read Gary's objections, how Russell Humphreys responds, and then how Gary responds. And so that they went back and forth for quite a while. And I'm pretty sure Russell Humphreys had the final word on it too. And so point is, if the critics are doing their homework and they're doing their due diligence, rather than just assert the same talking points or rescue devices, they should at least follow up by saying, by the way, how the creationists could respond and has responded to this is this, and this is how we'd respond. And that way we can kind of, I think, move forward in a more meaningful manner, rather than just always having to focus on the basic talking points. Anyways, Ben, Sam, maybe Ben, we'll start with you, as you, if I remember correctly, you had helium in zircon crystals as your number 4 piece of evidence, because 5 was C14. So What are your thoughts, brother? Are you, because of what Creaky Blinder said here, are you now going to take helium and zircons and move it out of the top 5, or are you leaving it in, and why?
I'm leaving it in. But you know, he seemed to think that there was a calculation involved in this, sort of like the salt issue. But in this case, what they actually did was they took these zircons out of the ground and they sent it off to a lab and just measured the diffusion rate. And they measured the amount that was in there. So his arguments about, well, there's radiation produces faults in the crystal structure and that makes it comes out faster or something. I don't know.
Is that this one here from Roger Weens? Let's see.
Sounds like what he was talking about.
Alleged that accumulation over time of radiation defects in zircons is significant. Kind of sounded like what Creaky Blinder was getting at.
Quite sure. I would have to, I guess, look at those references, but I think, I mean, I think the argument would have to be that somehow they're more fractured than the samples that were tested or something, because they measured the helium diffusion rate of the samples that they had. So any defects should be in those samples, and it would have affected the measurement. So I don't know. Maybe they're just saying, well, they could be different in different places or something. But anyway, that reference says it's only a factor of 2, so it doesn't make a big difference. I remember when I was researching this a few years ago, I found a criticism that they published, that the Young Earthers published in one of their journals, and Humphreys responded to it. And I think it was one of the temperature ones. It may have been the Locelt one, I think, was that one. And what all Humphreys did was he showed, well, I took all of his assumptions and did the math, and it's still bad for the old age position. You know, you take all their criticisms, you add them all up, okay, or at least in that specific case, and you do the calculation, which apparently Locelt did not do, and then you get a number of, like, it has to be younger than this amount, which is not old enough for the old Earth paradigm. And so it's like, even if they're right about everything, most of the time it doesn't solve the problem enough. There's just too much helium in those rocks for any reasonable old Earth scenario. And so that's why I think it's a really good argument. The other reason it's a really good argument is because it's one of it yields an actual young Earth date.
Yes. Yeah.
And so this is the one that I always tell people when they ask me that. They'll often say, well, how come all your scientific evidence gives a maximum age for the Earth and you don't have any actual dating methods that give you a young Earth age? We do. It's this one. Because the rate study showed that the amount of helium that's in there fits the helium diffusion rate and the initial amount, or that's coming from the decay, to 6,000 years. As you see there, the error bar is large, but it's right in the middle. It's 6,000 plus or minus 2,000 years. And that is a really good, that's really good evidence.
That's incredible, eh? I remember in your debate with Adam.
Curious Christianity.
Yeah, Curious Christianity. He had asked, and it wasn't the first time, but he's asked for a piece of scientific evidence that places the Earth at roughly 6,000 years, and boom. I mean, this. So if we wanted to just focus on mutation rates in the Y chromosome and mitochondrial DNA, we get the origin of humans at somewhere between 4,000 and 6,000. I say 4 to 4,500 because of Y chromosome Noah, if we want to get real specific. But then if we want to also limit the age of the Earth to roughly 6,000, then we go to helium and zircons. So we kind of have the best of both worlds. The origin of humans, and then with genetic entropy, I'd also say the origin of all life, really, since that puts shelf lives on genomes. And then here, like you pointed out, with the error bar plus or minus 2,000 years. In science, why is that so significant, that error bar, Ben?
That is a pretty large error bar, but we're dealing with things that are super uncertain to begin with. It's important to include error bars in your conclusions to show people the level of certainty that you have. I mean, I think this is acceptable for this kind of thing. I don't see that as a problem. I'm not sure what else to say about that. That would be a pretty large, what do they call it? I did this in analytical chemistry. We had to learn this, standard deviations. So that would be a pretty large standard deviation. So that's a little concerning about the data, but this type of thing is so wishy-washy. It's kind of like, you go look at radiometric dating.
Well, that's what I was thinking. Aren't the error bars in radiometric dating just massive?
They're huge. They're
right.
huge. And they have
well, I'm
to
looking
be,
at the plus or minus 2,000. I'm thinking like, well, that's nothing compared to what I've seen in dating methods.
Well, you have to compare it to the scale that you're using. So 2,000 plus or minus out of 6,000 makes it a pretty large error bar. Right. But they always say that all of our radiometric dates give us the same date. Well, they can only say that if they're using super large error bars.
Yeah. Right.
Because their dates do not give very similar dates all the time. They give widely divergent dates sometimes, and so they have to claim a large error bar too when they do that, to say that they're in the range that gets us what we want, right? So they do the same thing. It's standard practice in science. You tell people what your error bars are and let people make up their minds. The problem that I run into with a lot of evolutionists is they don't want to tell you that. They constantly want to tell you that the science is perfectly correct. And this seeps down to the popular level. People who don't study this stuff, who don't have a science background, they think things, and I've seen this in popular level writing. I wrote an article about this on my Substack once. I saw a political commentator claim it had something to do with J.D. Vance. J.D. Vance was talking about how he didn't see how he could reconcile the Bible with science in college, and so he became a Catholic or something. I don't know. But he mentioned young earth creationism, and this guy came back. His name is Aaron Wren, and he came back and said, well, yeah, because physics is 100% accurate. And it's like, what science classes did you take in college? What science have you studied? This stuff is never 100% accurate. What are you talking about? And the reason they say these things is because they're told this by the popular media, including by educational authorities. They're told that this stuff is fact. It is certain. It is 100% correct and true. And they believe it. And it's just bull crap. and scientists know that it's bull crap. But they tell the public different anyway. It frustrates me because people don't understand how science works, and they think they do, and they think that we're crazy because of it, because physics is 100% accurate. I could rant on this for a while, but physics is never 100% accurate. That's why the error bars exist. That's why I was taught about standard deviations in college. You have to deal with, even when you run the same experiment 100 times in a row with the same equipment, it will give you slightly different values. And you have to statistically deal with that and get and calculate what you think the best value is out of those results. It's never the same.
Well, it's
it's the same, and it's 100% until you use one of their lines of evidence to show how the Earth is young. Like you send a rock to a lab of known date, and then all of a sudden, well, there's contamination, there's air in the laboratory, the physics of biological decay are off, there's something to preserve it, or, oh, there's fluctuation in the environment, no more uniformity, and then all of a sudden they make the argument for us that there's problems.
Yeah, I mean, I've had these arguments for decades at this point online. I used to argue about this stuff before social media existed on forums and stuff, and that exact tendency is sometimes evident on both sides. But I'm trying to be an honest person, right, and look at it, and what I find and see in the way people deal with science is exactly that. When your position is attacked, all of a sudden, all these things become okay. But it's only when the other team says those things that you say, well, that's not okay. And this is why I've become more and more interested in philosophy of science in years since, is because I want to try and understand how people are really thinking about science, what science really is, and how you can make these kinds of claims when there are problems with every position and there is inaccuracy in all data, and so in one sense, I would like to offer a little bit of a thing here. The problem of the model that creationists need to explain the rapid radioactive decay, that is the one big remaining unsolved problem in creation science. Is how is it that 600 million years of radioactive decay happened during the flood, and then the rest of it happened during creation week? There is no real good theoretical model for that. And that's the one big problem remaining. It used to be two problems until I learned about the ASC, right? Those were the two. I used to say this to people. These are the two big scientific problems. Well, the ASC solves one of them. When I finally understood it, I'm like, yep, that's not a problem, actually. And the remaining big problem is the radioactive decay. We do know that radioactive decay is not invariant. It does vary with heat and pressure. It just doesn't vary enough to account for the increased speed. So that's one area where creation scientists need to come up with something and figure it out. So there are problems with every view. I take this view because I think there are the least amount of problems with it. And I also include the Bible as historical evidence as well, which they don't do. But I've learned in philosophy of science that oftentimes when you have conflicts between theories, there are often disagreements about what counts as evidence. There are disagreements about how to judge various evidence. So we say that the Bible counts as evidence because it's a historical record of the past. They say, no, it doesn't. You have to prove your position with science only. And we just say, well, why? And then you can point at things that they do where they use historical records when it's convenient for them. So they'll use historical records of the date of Mount Vesuvius eruption in AD 79, for example, to calibrate radiometric dating methods. They do it all the time. And I look at that and I say, well, you're using a historical record to verify the date of the eruption of Mount Vesuvius and using it to calibrate your data. So why is it illegitimate to use historical records to say, we know that Mount Vesuvius erupted in AD 79 because of the historical record? On our side, on the creationist side, we know that the earth was created about 6,000 years ago from the historical record. Okay, and so that counts as data that has to be explained by a scientific model. And until your model explains that data, it's not adequate. Okay, and they will just say, well, no, that doesn't count as an observation or whatever, and they don't want to use it. But they use historical records in other situations. So it really is part of our position that the Bible counts as an accurate record of the history of the world. And we're trying to come up with scientific models that are in accord with that and explain that. But the other side does the same thing in different ways. There's always that feature of science where you're trying to make your models coherent with each other, and say that, well, we already know because of the fossil record that this dinosaur or whatever is this old, and so we have to figure out a way to make this other data cohere with that. They do it all the time, and then they deny that they did it. But it's actually remarkable how much of the old Earth paradigm is based off just radiometric dating, and it all comes from there.
Right.
I just don't think they have near the amount of really good arguments for, it can't be this old, right? We have tons of them, all kinds of different evidence that is independent. Whereas most of the older stuff, if you dig into it, it goes back to radiometric dating, almost always.
That's their main appeal. That and distant starlight. Yeah, I think there's a lot of good information there, a lot of good points. I like that this was a thorough dismantling of Creaky Blinder. That basically concludes the video. I mean, we addressed the majority of his points there, and I appreciate that you offered up a roughly 60-minute technical presentation, which, Ben, I'm already excited to go back and listen to, which was, I think, a good way to set the foundation. We played Creaky Blinder's first assertion that there is no good evidence for young Earth creation. He even compared it to a flat Earth, which you absolutely dismantled. And the points that you brought up, the heat problem, for example, which he kind of hinted at a little bit, if we're going to look to accelerated decay, I think we could model build. I think if we start with the idea that we don't necessarily know how hot the core was in the pre-flood world. It's extremely hot now, of course. And a good research project is basically answering the question, how much of the heat, including through accelerated decay processes, could be taken into the core, could be taken into the earth, because we could put forth a model that basically suggests that a lot of the heat that our model advects or transfers a lot of the heat downward, vents a large fraction into space, which is in a way the only real exit. And then a small amount could have been utilized to rapidly form coal, oil, natural gas. We'd have to answer the question, how can we scientifically move a lot of that heat into the core? The point I'm trying to make is I don't think it's an impossible challenge. I think, like the distant starlight challenge, I think with enough minds coming together, I think we could put forth a really good, strong model, even on the heat problem challenge. But it doesn't take away. So the critics, they like to jump, Ben, to the heat problem.
Oh yeah,
we can brainstorm some good ideas, but then they dodge the evidence for accelerated decay, as if that just magically takes away the helium and zircons, the radio halos, the fission tracks. It's like, yeah, we can talk about the heat problem, but clearly the arguments they're putting forth, right, Ben, like we're seeing here from Creaky Blinder to answer the helium and zircons, those answers don't work. They've been addressed. And you made a good point. Even when we grant them what they want, Ben, on the salt accumulation, on this issue here with the helium and zircon crystals, and many others, even in the world of genetics, we can grant them certain things, and it still doesn't save the day for them, as we've seen. But anyways, Ben, you're going to say so. Actually, you know what, gentlemen, let's move into closing words. So this has been a great show. Ben, let's start with you. This has been a ton of fun. 3.5 hours flies by. I enjoy these response videos. I know the audience does as well. So maybe we'll have to do another one of these. We'll pick another. There's more than enough videos to respond to out there. That's for sure. So it's good for business. It's good job security when the critics are responding. So Ben, let's throw it over to you, brother. Excellent job. I appreciate your research. And Any final words, final thoughts, anything you wanted to say to what I said there, of course, as well? Go ahead, brother.
Yeah, I would just say that the loudest voices against our position are always going to focus on the problems with our position. And so you have to listen to people who hold the position to get the reasons why we do hold it. And that's what I tried to do tonight, is give a really good survey of the best scientific evidence for our position, which you will never hear from the critics. You'll never hear it in school. You'll never hear those things from professors. It is buried in the scientific literature in some cases, but they will never tell you this. You're only going to hear it from young earthers, and who are consistently discriminated against in the academy. So we do not have platforms that are considered credible in society. But if you want to learn our position, you have to learn why we believe it and not what is wrong with it. There are things that are problems in it, but everybody has problems. This is science we're talking about. It's not the Bible, right? So I appreciated the chance to give that evidence. I feel like people don't hear it enough. And I know that in my own friends that I talk to about this stuff, I've had this experience very recently. I think I talked about it either before the show or something, but some friends of mine, I gave several examples of what I talked about tonight, and they were just like, nobody knows about this stuff. And so I really appreciate your platform, Donny, and the opportunity to come on and give this evidence so that people can hear about it.
Amen. I love it. You're always welcome on the program. And I see that frequently where, like, for example, the pieces of evidence that you presented, people that are open-minded, people that you meet in your personal life, because we're dealing with a lot of the most militant, adamant critics on YouTube, because this is the world of the internet, right? So we're confronted with the loudest, like you said, anti-creationist. But your general population and people that we know in our personal lives, we present a lot of this evidence, and in many ways their mind is blown. Like, I've never heard of this before. I've never seen this before. And so, Ben, I think it's so important to do what you did and spend 60 minutes and say, hey, here's what I believe are 5 of the best, well-supported lines of evidence for young earth creation. Get people thinking, open people's minds. So, Ben, excellent work, brother. This was a ton of fun. As always, inspiring philosophy, William Lane Craig, Redeem Zoomer, and now Creaky Blinder.
You got to do that meme. It's like you're doing that meme with the Grim Reaper going to the doors.
Yeah.
I'm not sure I did that well, but I don't know.
You did good, brother. You did good. So those in the audience are going to be left in suspense. Who's the next critic we will demolish? And so, Sam, my man with the plan, I appreciate you being here, brother. You did an excellent job countering Creaky Blinder's points against what you were saying, the transcendental argument and evidence for God, so on and so forth. So great work, brother. I really appreciate you being here with us. Final words, final thoughts?
Yeah, thank you guys for having me on. I did appreciate it. I love spending my evenings, talking about this stuff. So as a Christian, I have the ability to actually, weigh the evidence on both sides. I suppose I could join the likes of, William Lane Craig or the critics of biblical creation, but Christians as well. What do I mean by that? This idea that evolution in an old earth somehow falsifies the idea that there is a God it's a non sequitur. Even if we were to grant that evolution in an old earth was true, it still does not support your atheistic view of reality. That said, I'm not a biblical creationist, because I am a biblical creationist because I have weighed the evidence. I mean, I've spent years listening to debates going back and forth on both sides, and I don't know. I just feel like we got the good arguments. I don't feel like they have any good arguments. And that's about it.
I completely agree, brother. I completely agree. So, okay, Sam, Ben, my brothers, you guys are great. This was a ton of fun. I'm already looking forward to the next one. To those in the audience, thank you for sticking with us and being willing to hang out with us for 3.5 hours. So Creaky Blinder has his work cut out for him. That is for sure. He's got a lot to address. He's got a lot to respond to. And maybe it'll just be easier if he agrees to a debate sometime in the future. Okay, gentlemen, you guys enjoy your night. To the audience, again, thank you so much for tuning in. And also thank you very much for the support, the comments, the feedback, and even the objections and challenges, because those really help to make these programs that much more comprehensive, that much more engaging, and in my opinion, memorable. God bless. Standing for Truth is out.